am good to start my evaluation. So first of all, I have to build a confusion matrix, and it's confusion matrix because of some confusions associated while understanding the terms which are quite related to each other. Okay, like true positive, false positive, and all. So we'll pass on this data to the metric function. So this metric package, right? In sklearn, you have a metric package that can be used for linear regression or logistic regression, anything. So you have a confusion matrix function to which you pass your actual data and the predicted data, and this is what your confusion matrix is. Okay. So first of all, this confusion matrix is not that intuitive. So what we do, we want to convert it into this format, right? So this data, we will pass it to the Seaborn package. I hope you guys are aware that for plotting, there are 3 to 4 main packages in Python. They are matplotlib, that's one. Then Seaborn, which is better. Seaborn actually is built on top of matplotlib. So it's like inheritance we were talking about, right? So Seaborn is like a child of the matplotlib. If the matplotlib package is somehow corrupted in your system, Seaborn will also not work. Okay, it's like a child of matplotlib package. Similarly, there are other packages like Plotly. Okay, Plotly is another package, and similarly there are other packages, quite good packages that can be used for the graphing and charting. You can install these. There is a okay. There are other packages also. Okay, so you can do that. So let's go to this Seaborn, which is the one of the best ones. So we have the heat map. Heat map, I hope you all are aware, is like this chart here. The colors, they specify the intensity or the heat. Okay, so it may so happen that the darker color is having the higher values, or vice versa. The lighter color has the higher values. We can invert it. Okay, so this is my heat map where I have passed on the confusion matrix, and that's it. This annote is like annotation. It's fine. You don't need to do everything. It's fine. It's fine. But yeah, definitely please go through these. These are good packages. Each package has some additional features. Okay. Annotation true means ये जो आपको यहाँ 46, 3, 3 ये जो लिखा दिख रहा होगा आपको मेरी स्क्रीन पे, that's what it signifies, the annotation. Okay. Annotation का मतलब है कि ये जो values हैं 46, 3 and all, ये color के साथ साथ वो values भी दे दो. Okay. Very good. And here if you see this specifies the intensity, and here you see its lighter color is having higher intensity, and I can revert it also. Okay, that can also be done by passing a parameter inside this heat map. Perfect. So now the point comes here is how to read this confusion matrix. So here is my actual data. Here is my predicted data, right? Say, Abhi, just to understand it, let me keep it simple to explain you. This is my positive class. Say this is my negative class. Don't go by 0 and 1, just leave it. And say again, this is my positive class and this is my negative class. Okay. So now can you guys tell me what is the value of true positive in this chart? What is the value of true positive? If I'm saying this is positive, okay, good. What is true negative? What is true negative now? Very good. Very good. So true positives means जो positive है उसको positive बोलना है और जो negative है उसको आपने negative बोला. Now what is a true negative? False positive. Can you tell me the false positive? Guys, the false positive value now? Okay. So false positive, what do you mean by false positive? Okay. The question is, let me say, guys, this is A. Let me say this is A and this is B. So you are saying A or B, please. A or B. Okay. So I am talking about false positive means something that you predicted as positive, but you were wrong. You were false. You predicted it positive, but it was not. Understand it, okay? You predicted something as positive, but it was not positive. Falsely predicting the positive class. You says it positive, it was not positive. So you predicted this as positive, but it was not positive means this. Remember, that's where the confusion matrix, okay? So falsely predicting the positive class. If you have any doubt. See, if you have any doubt, I'll share this link. This is one of the simple link to just read it. False positive is you predict something as positive, but they are not. So that's false positive. And false positive is known as type 1 error. So in interview, they ask you, right, what is type 1 error and what is type 2 error. So there are two kinds of errors, type 1 and type 2. Okay. So going back to this thing, but yeah. So there are two kinds of errors. So both of these are actually the errors. Okay, so false positive is the type 1 error and false negative is type 2 error. So false negative as in you are predicting something as negative. Say if this is the predictions and these are the actuals. And if this is the positive class and this is the negative class. So this is the positive and this is the negative class, for example. So false negative is you are predicting something as negative. That means this pillar, but actually it was not negative. Rather, it was positive. Okay. This is the actual, this is the predicted, you predicted negative, and this was actually the positive one. So this was the line. So where the intersection is here, right? So this intersection is the false negative or the type 2 error. Okay. Now some interesting thing that comes out of this chart. We will keep discussing this chart in the later classification models, but there are some important terms that comes out of it, and they are like false positive rate, true positive rate, and all. So the very first and the important thing that we should focus on is accuracy. So accuracy of this model is true positive plus true negative divided by the whole, by whole, right? So that means 46 plus 62 divided by 46, 62, 3, 3, everything. You will get the accuracy of the model. Okay. So that's what the accuracy of this model. Okay. And that accuracy can also be calculated using this function. In the matrix, you have accuracy function. So you can calculate, okay, the accuracy of this model is somewhere 94%. But this is what it may not be right. We have to check, okay, further. It may be that on future data how this model belongs, whether the data was good enough. अभी ये 94% accuracy it seems to be very good, but हो सकता है कि मेरा data बहुत limited था जिसमें मैंने ये model चलाया. ठीक है, so don't rely on that for now. But yeah, it seems to be a good accuracy. Now ये accuracy को check करने का there is another method, okay, which is known as ROC AUC curve. Okay, so what the ROC AUC curve tells you is, first of all, this is known as a receiver operating characteristic curve. It's a curve between the false positive rate and the true positive rate, FPR and the TPR. So if you look at this, we will plot it. If you look at this, guys, so this chart is known as the receiver operating characteristic curve. What do you mean by that? We will talk about it. But remember, first of all, what it is. It is a FPR versus TPR chart, which is the false positive rate versus the true positive rate. And further, by looking at this chart, we try to understand if the false positive rates increases, how the TPR is behaving. So whether the true positive rates are increasing or decreasing. Okay. For that, we have to understand what FPR and TPR are. But first of all, let's focus on what this chart talks about. So this chart, the ROC chart, tells you the relation between your FPRs and the TPRs. Like if your false positive rates are increasing, is your true positive rates are increasing or not. So the ideal value out of this chart should be where the false positive rates are 0 and the true positive rates are 1. Obvious. That means something like a straight line like this is the best one, because you want 0 false positive rate and 1 true positive rate, right? False positive to kya hai aap? I'll talk about that, because we know that false positive is an error, so we want 0 error. And true positive is definitely something which is important, like because मॉडल से प्रेडिक्ट क्या करवाना है आपको, और जो चीज प्रेडिक्ट करवानी है क्या वो उस चीज को सही से प्रेडिक्ट कर रहा है. कभी भी आप क्लासिफिकेशन मॉडल का जब हाइपोथेसिस बनाते हो तो उसमें आप अपनी पॉजिटिव और नेगेटिव क्लासेस बड़े ही क्लियरली डिफाइन करते हो कि भाई मेरी ये नेगेटिव क्लास है, ये पॉजिटिव क्लास है, सो दैट कि आप किस चीज में इंटरेस्टेड हो आपको वो क्लियर रहे. मतलब अगर मेरी पॉजिटिव क्लास है कैंसर प्रेडिक्ट करना और नेगेटिव क्लास है नॉन कैंसर, that means I am more interested in identifying people whether they have cancer or not, okay, rather than identifying those people who don't have cancer. ये सुनने में सिमिलर लगता है बहुत ज्यादा, बट ये नहीं है. मतलब ये है कि मेरा फोकस किस चीज पे है. क्या मैं कैंसरस पेशेंट्स को ज्यादा से ज्यादा आइडेंटिफाई करना चाहता हूं, ओके, सो दैट आई कैन गिव देम प्रॉपर मेडिकेशंस. So that's why it's all depend on the problem that you are trying to solve. Okay. So first of all, understand that ROC curve is a curve that is plotted between the FPR and the TPR, and FPR should be 0, TPR should be 1, but real world में ऐसा होता नहीं है क्योंकि कुछ ना कुछ एरर्स मॉडल में होती हैं. इसलिए आपको ये जो दो कर्व यहाँ दिखा रहा हूं मैं, ये दो अलग अलग मॉडल के कर्व्स हैं. सो गाइज, ये जो ग्रीन कर्व दिख रहा है वो एक अलग मॉडल है, ये ब्लू कर्व एक अलग मॉडल है. ये दो अलग अलग मॉडल है. मैंने यहाँ आपको साथ में प्लॉट करके इसलिए दिखाए हैं कि इस चार्ट से हमें इमीडिएटली पता लग जाता है कि आउट ऑफ द 2 गिवन मॉडल्स विच मॉडल इज बेटर. ओके, आउट ऑफ 2 क्लासिफिकेशन मॉडल्स, मान लो ये एक लॉजिस्टिक रिग्रेशन का है और एक सपोर्ट वेक्टर मशीन का है, तो द वन विच वन इज बेटर, ऑब्वियसली द ग्रीन वन इज बेटर. व्हाई? बिकॉज ये जो एक हाइपोथेटिकल लाइन मैंने बनाई है यहाँ पे, सेंट्रल लाइन, it's just a hypothetical line. I'll explain you ये क्या होती है. But the point is, अगर मैं एरिया अंडर द कर्व की बात करूं, AUC, एरिया अंडर द कर्व, इस कर्व के अंडर टोटल एरिया कितना है, तो दैट वैल्यू कैन बी समवेयर बिटवीन 0 to 1. एरिया अंडर द कर्व कैन बी बिटवीन 0 to 1. So the more the area under the curve, the better the model. And actually the area under the curve is nothing but your accuracy. Okay, so ROC कर्व से जो AUC वैल्यू मिलती है वो आपका accuracy ही होती है. जितना ज्यादा वो वैल्यू उतना अच्छा. तो अगर आप यहाँ देखेंगे तो ग्रीन और ब्लू के बीच में there is difference of some accuracy. So green is more accurate as compared to the blue. So that's how you interpret this particular chart. So, for example, if I have logistic regression, I'm coming to that, Gulzar. So if I am having logistic regression, and I'm trying different values of lambda, the regularization strength. So, and I want to see out of these two models, means logistic regression with two different regularization strengths are two different models, right? So which one is better? I can simply plot it and check it. ये एक डेटा साइंटिस्ट के लिए इतना जरूरी नहीं है, बट जब आप किसी बिजनेस एनालिस्ट को ये दिखाओगे या किसी स्ट्रेटजी टीम को दिखाओगे अपने कंपनी में सीईओ, सीटीओ, सीएक्सओस को, तो दे विल अंडरस्टैंड दिस बाय चार्ट, राइट, इमीडिएटली, ओके, क्या बोलना क्या चाह रहे हो. तो दैट्स व्हाई द चार्ट कम्स इनटू पिक्चर. आपके लिए हो सकता है इसकी उतनी वैल्यू ना हो क्योंकि आपने तो एक्यूरेसी देख ली, एफपीआर, टीपीआर देख लिया, आपको पहले से पता है वो सब चीजें, तो यू आर नॉट हैविंग एनी प्रॉब्लम. ओके, सो अंडरस्टैंड दिस. सो एफपीआर वर्सेस टीपीआर का ये हमारा चार्ट है. इसको प्लॉट कैसे करते हैं, लेट्स सी दिस. And even before we plot that, this red or orange line, whatever you guys are able to view this line is known as a guess line, a wild guess. It's like a guess line. What I mean by that is it's like कि आप बिना मॉडल के just assumptions पे काम कर रहे हो. As in, कोई पेशेंट मेरे पास आया, मैंने बोला चलो भाई इसको कैंसर है, दूसरा है, मैंने कहा इसको कैंसर नहीं है, मैं बस रैंडमली किसी को भी कुछ भी बोलता जा रहा हूँ. इट्स लाइक अ रैंडम गेस. दैट्स वेयर दिस लाइन इज. तो ये एक रेफरेंस लाइन है बस, कि इसके ऊपर ही सारे मॉडल्स होने चाहिए, क्योंकि इसके नीचे या इस पे अगर कोई मॉडल फॉल कर रहा है तो इट इज नथिंग बट लाइक अ रैंडम गेस. इफ सम मॉडल इज फॉलिंग लाइक दिस, सो इट्स लाइक you can say 0.5% accuracy, right? This line denotes 0.5% accuracy of your model. 50% accurate. If a model is 50% accurate, means half of his predictions will always be wrong, which is not good, right? Yeah, Gulzar. So guess line is like you're guessing, right? Randomly. Okay. So where you, if you're good enough, you can be 50% time good, right? 50% time not right. That's what the thing is. But guess can be even worse. कि आप कभी भी करेक्ट नहीं हो क्योंकि वो तो गैस है, बट ये फिर भी एक वो गैस लाइन है जो 50% एक्यूरेसी को रिप्रेजेंट करती है. ओके, तो ये किसी मॉडल को रिप्रेजेंट नहीं कर रहा हूं यहां मैं, ये सिर्फ एक रेफरेंस के लिए मैंने प्लॉट किया है कि एनी मॉडल विच इज अबव दिस इज एटलीस्ट बेटर देन रैंडम गेसिंग, बट एनी मॉडल विच इज गिविंग यू द आरओसी प्लॉट बिलो दिस इज नॉट गुड. ओके, so definitely the area under the curve of both of these models, guys, is less than 1, because I told you this value is 1, right? This value is 1. So if I plot something from here down the line, and from here if I connect this dot, that will actually be the value 1. But none of these are actually 100% accurate, none of these two models. Now how to plot this? It's very simple. Again, we just need the predicted value and the actual value. Guys, 1 second, getting a call, 1 second. Okay, guys, yeah, sorry, got a call. So Nishtha, there is, see, the ROC and AUC are two different things. ROC is the name given to the plot, okay? This plot is known as ROC curve. This graph is known as ROC graph. And the area under this graph is known as the AUC, the area under the curve, okay? So mathematically speaking, if you plot any charts, right, any chart, even a square or a square root, anything, so any area that chart covers with respect to the x-axis, that's the area under the chart. So every chart has an area under it. So that's what it is. And how to plot this curve? Very simple. You have a function known as ROC curve function, wherein again you pass the data that you pass to the confusion matrix. Okay, and it gives you 3 arrays as output. Okay, the output that's coming here are, guys, 3 arrays: first array, second array, and third array. Okay, so the first array that is coming out of it is known as the false positive rate. The second array that comes out of it is known as the true positive rate. Okay, and the third one that comes out of it is some thresholds. Okay, you can ignore this. It's just 210. It's just a threshold value. Ignore it. Now, if you get the FPR and the TPR, like 2 arrays, you can simply plot it, right? On the x-axis, you will put the FPR. On the y-axis, you will put the TPR. So, using matplotlib.pyplot, you will plot a scatter plot. Okay. So there are 3 points, right? 1, 2, and 3. So you will simply plot it. Let me show you this. ओके, तो मैंने यहाँ क्या किया गाइस, ये मेरा पहला मॉडल था जिसका FPR TPR मैंने यहाँ सेव किया हुआ है, और ये मेरा दूसरा मॉडल है जिसका FPR TPR मैंने यहाँ सेव किया हुआ है. ठीक है, what I mean to say here is, okay, what I mean to say is कि ये मेरे पहले मॉडल की प्रेडिक्शंस हैं, ये मेरे दूसरे मॉडल की प्रेडिक्शंस हैं, राइट? एक्चुअल वैल्यूज तो दोनों में सेम ही रहेंगी. तो दोनों मॉडल्स के मैंने ROC कर्व आउटपुट्स निकाले. तो ये जो आउटपुट आया ये पहले का है. सिमिलरली मैंने एक और बार एग्जीक्यूट किया तो दूसरे का भी आ गया मेरे पास, और मैंने यहाँ पे पहले के FPR TPR सेव किए हुए हैं. ये पहले मॉडल का FPR और TPR है, ये दूसरे मॉडल का FPR और TPR मैंने सेव करके रखा है. तो यहां पर बस मैंने आपको पहले मॉडल का प्लॉट करके दिखाता हूं पहले तो ये पहला मॉडल मैंने यहाँ प्लॉट किया, उसके FPRs एंड TPRs यहाँ प्लॉट हो गए, एंड आई नीड टू सिंपली कनेक्ट दिस. ओके, तो कोई भी चार्ट बनाने के लिए या ग्राफ बनाने के लिए हमें पता है कि मिनिमम 3 पॉइंट्स हमें चाहिए होते हैं. ओके, वी ऑलवेज नीड मिनिमम 3 पॉइंट्स. बट द क्वेश्चन इज, एक मॉडल मुझे 3 FPR TPR क्यों दे रहा है? क्योंकि किसी एक मॉडल का तो एक ही FPR या एक ही TPR होगा, राइट? तो बिल्कुल सही बात है. तो ये उस मॉडल का एक्चुअल FPR या TPR है. ये तो बस वो आपको प्लॉट करने के लिए 0 और 1 अपर बाउंड्स दे रहा है, इसका और कोई रेलेवेंस नहीं है. क्योंकि हमें पता है कि अगर आपको कोई भी चार्ट बनाना है, यू नीड अ स्टार्टिंग पॉइंट, यू नीड अ एंड पॉइंट, एंड यू नीड अ इंटरमीडिएट पॉइंट, बिकॉज अदरवाइज तो एक लाइन बन जाएगी. अगर आपको कर्व बनाना है, यू नीड मिनिमम ऑफ 3 पॉइंट्स. इफ यू नीड अ लाइन, you need minimum of 2 points, right? But since it's a curve, you need minimum of 3 points. Where this point is the actual FPR TPR, these are just the references or the thresholds, whatever you want to say, the minimum and the maximum thresholds, the 0 and the 1 values. Okay, absolutely, Gulzar. So sometimes मतलब people get confused कि ये 3 आउटपुट क्यों दे रहा है मुझे. तो उसके पीछे सिर्फ वो ये रीजन है कि ये चार्ट बनाने के लिए 3 आउटपुट दे रहा है, बट मिडल वैल्यूज आर द एक्चुअल वैल्यूज ऑफ योर FPRs and the TPRs. So now I have plotted this chart for you. This is how it looks like, but this is not good. I need to connect the dots, and to connect the dots, we know that there is another function which is known as a plot function, right? In matplotlib.pyplot, Okay, so yeah, we have plot function, so which gives you the plot. So let me just run this. So this is how it looks like. Okay, and now I already have the another models FPR TPR also. So let me uncomment this also, and also its plot function. So I get these two. Okay, but since I want a reference line also, a guess line also, so since it's a line, I need only 2 points, 0 0 1 1. So x0 y0 x1 y1. So this is what I'm doing, guys. You can say this is my guess line. Yes.
Sir, two models as in?
As I told you, two models as in logistic regression model, but with two different values of lambda, right? पहले आप लैम्डा की कुछ वैल्यू के साथ ट्राई कर रहे हो, फिर लैम्डा की दूसरी वैल्यू के साथ ट्राई कर रहे हो। जैसे आप ग्रिड सर्च सीवी करते हो, अलग अलग हाइपर पैरामीटर्स का मतलब क्या हो गया, अलग अलग मॉडल्स हो गए ना। अगर आपने KNN मॉडल को K3 के साथ बिल्ड किया, वो एक मॉडल कहलाएगा, और K = 5 के साथ किया, वो एक अलग मॉडल कहलाएगा। तो when I say two models, I means to say logistic regression model, but with different hyperparameters, so that I can see which hyperparameter combination is giving me the best result, right?
Okay.
Is it clear?
Yes, sir.
Okay. तो ये तो सिंपल गैस लाइन है आपकी। ये आपका x इसके वैल्यू है x0 y x0 and 1 y0 and 1। तो पहला जो प्लॉट होगा वो x की ये वैल्यू है, y की ये वैल्यू है 0 0, फिर x की वैल्यू y की वैल्यू, राइट। आई होप ये तो क्लियर है ना सबको। ये आपका x एक्सिस होता है और ये आपका y एक्सिस होता है, ठीक है, एरे ऑफ x एंड y, राइट। तो ये मेरा प्लॉट बन जाएगा यहाँ पे। तो रिमेंबर दिस इज व्हाट the ROC curve is. So you didn't did the ROC curve, right? Guys, yes or no? Means you didn't did ROC curve earlier, or did you? Yes or no? Okay, you have done in R, na? Good. Do we always plot ROC with one reference point only? Because I have seen ROC having an R. See, it's just the way of plotting. I understand, Vipul, you are right. Somewhere you get it arc also. But see, the point here is arc or no arc. It's just whether you are able to graphically represent it. That's what is important. Okay. Because as I told you, what I'm interested in the actual value of the FPR and the TPR for the model. And I will have only one value of FPR and TPR, right? How can I have multiple values of FPR, TPR for the model? So it's just like when people plot it, they plot it that way. But this is how it actually should be. Okay, because you cannot have multiple values of FPRs and the TPRs. For one model, it will be one. Okay, and the more important point of ROC curve is to compare the models graphically. That's it. To compare the models graphically. That's it. Nothing more than that. Because accuracy itself is enough to tell you which model is good or not. As compared to the other. This is just graphically proving it. That's it. And further, it's telling you the relation between FPR and the TPR. Like if you're trying to, for example, if your FPRs are increasing, how the TPR will be behaving. You don't want that to happen. But आपके मॉडल में फिर भी आप देखोगे तो कुछ फॉल्स पॉजिटिव रेट्स हैं जिसकी वजह से ट्रू पॉजिटिव रेट आपका घट गया है। तो यहाँ सीधा सीधा में ये पता लग रहा है कि फॉल्स पॉजिटिव एरर्स है मेरे मॉडल में, ओके, जिसकी वजह से मेरा ट्रू पॉजिटिव की एक्यूरेसी घट रही है। बट स्टिल इट्स 94% एक्यूरेसी में है, तो आई एम फाइन विद इट। ओके, तो
सर,
यस,
So we can apply any algorithm, and then through confusion matrix we can find the accuracy of different models, and then we can apply all those models. If we apply together on the ROC curve, it will show for each and every model. Like if we have applied SVM and linear regression and logistic regression as well, तो वो तीनों model का it will show on the ROC curve.
Only classification models, no regression model. It is only for classification models.
Okay.
Okay, it's not for regression models, right? Because you cannot create a confusion matrix for regression model.
Yes.
Because it's divided by classes. You can have a classification model, or you can have a confusion matrix for multi-class classification also. यहाँ ये 2-class classification का है. अगर multi-class classification हो तो यहाँ पे ये further और आपका increase हो जाएगा. तो confusion मतलब matrix क्लासिफिकेशन के केस में ही बात होती है. तो मल्टीपल क्लासिफिकेशन मॉडल्स को आप आपस में कंपेयर कर सकते हो using the confusion matrix, ROC, AUC curve and all. This is how the multi-class will look. Say class A, class B, class C, A, B and C. This is how it looks like, and this diagonal will always be the accurate values. It's like what you predicted is what you got, what you predicted is what you got, right? But other than that, everything else falls under the category of misclassification. Okay, that's what the misclassification is. And then there is something known as misclassification rate in confusion matrix, like how many records are misclassified. That's misclassification rate. So like you have a true positive plus true negative divided by the total gives you accuracy. Misclassification rate is the two errors, type 1, type 2 errors का sum divided by the total. That is your misclassification rate. How much data is misclassified, or what percentage of data your model is misclassifying. So that is misclassification rate. So normally whenever you sir is misclassifying lack of accuracy. Aha, Gulzar, it's like the reverse. It's like the mirror image. Okay, reverse of each other. So if accuracy gives you the rightness, the misclassification gives you the wrongness of the model. Okay. Different threshold, we get different values of TPR, FPR. So in order to visualize this threshold is best suited for classifying. Do we set threshold or the model decides published thresholds? So Harshita, you are talking about which threshold? 1 second. Because I told you that this is also a threshold here, right? You're talking about this threshold, or you are talking about the minima and the maxima, this thing. You're talking about this threshold. Okay, so if you are interested, I'll tell you about this later because I want to keep it simple. But if we want, we can change this. Yeah, okay, Harshita. We can change or we can get multiple values based on these thresholds. So there is some detailed explanation. Okay, so if you are interested, I'll tell you. But for the layman or the basic visualizations, you don't need it. That's where even someone was asking, right? I forgot that they see that this curve is coming as a curved image instead of like this diamond, right? So that's we can control by changing the thresholds. Okay, so if you're interested, I'll tell you later. Okay, in another model, but it's not mandatory to change these thresholds. Okay, however, if we want, we can, and then that curve can also be plotted for multiple values. So currently the threshold is only 3, like minimum, actual and the maximum, but we can generate these values for intermediate thresholds as well, and then that curve will become a bit smooth as compared to this curve. You guys can read it, okay, and then I'll explain you. So that's where the threshold plays a picture, but I don't actually talk about it. Why? Because in general you have only one FPR and the TPR, so not to confuse you guys with different threshold values, I don't touch that. Okay, read about it if you want, we can talk about it. Okay, but if it's generating the confusion, I would request to avoid it. Okay. So coming back to the confusion matrix. So we talked about that confusion matrix can be built for multiple models. All needs to be classification models. Confusion matrix can be built for the multi-class also, binomial also, like two-class classification also. And this model or this graph immediately tells you the accuracy and the misclassification, two things, plus the true positive and the false positive value, a type 1 error and the type 2 error. So in interview, if someone asks you, you need to explain these values and what all we discussed. Okay. Now, as an advanced user, if you go to confusion matrix, so you not only look for accuracy or misclassification rate or the ROC AUC curve, you look for few additional things, and they are known as the precision, the recall, the F1 score. So we will talk about those in the maybe naive Bayes or the another KNN model or random forest, but I will just touch basics about those. Let's see this. Okay. So what happens, guys, is accuracy, misclassification and all those things are good enough to tell you whether a model is good or not. Okay. But as I told you, जब हम hypothesis बनाते हैं machine learning में पहले, तो हम एक negative class बनाते हैं और एक पॉजिटिव क्लास बनाते हैं, राइट? तो ये देखने के लिए कि मेरा मॉडल मेरी नेगेटिव क्लास पे ज्यादा अच्छा बिहेव कर रहा है या मेरी पॉजिटिव क्लास पे ज्यादा अच्छा बिहेव कर रहा है, वी नीड समथिंग एडिशनल व्हिच आर नोन एज प्रिसिशंस एंड रिकॉल्स. मतलब ये है कि मेरा मॉडल पॉजिटिव क्लास पे अच्छा बिहेव कर रहा है से मतलब ये है कि जब भी मेरा मॉडल कैंसर किसी को बोल रहा है तो उसे कैंसर है, तो मतलब कि पॉजिटिव क्लास पे बड़ा अच्छा बिहेव कर रहा है. नेगेटिव क्लास पे अच्छा बिहेव करने का मतलब है कि जब वो किसी को कह रहा है कि भाई तुझे कैंसर नहीं है, तो उसे कैंसर नहीं है. तो ये चीज हम प्रिसीशन और रिकॉल से पता लगा सकते हैं, क्योंकि जैसा मैंने बोला कि मेरे लिए क्या इंपॉर्टेंट है, मेरे लिए पॉजिटिव क्लास को प्रिडिक्ट करना ज्यादा इंपॉर्टेंट है या नेगेटिव को प्रिडिक्ट करना. क्योंकि आप ऐसा सोचो कि किसी को कैंसर था और आपने बोला नहीं है, वो बंदा मर सकता है थोड़े दिन बाद. दैट मीन्स फॉर यू द पॉजिटिव क्लास इज मोर इंपॉर्टेंट. बट ऑन द अदर साइड, इफ से द नेगेटिव क्लास कि भाई किसी को कैंसर नहीं था, आपके मॉडल ने बोल दिया उसे कैंसर है, ठीक है, ये भी एक गलती है, बट ज्यादा से ज्यादा क्या होगा, दैट पर्सन विल गो फॉर सेकेंड ओपिनियन, और इफ नॉट ही मे स्टार्ट द ट्रीटमेंट. Though if he start the treatment it's a bad thing, but I'm still telling you कि ये आपको डिसाइड करना है, being a data analyst and a business analyst rather, your business will tell you कि उनके लिए क्या important है. As a data scientist you cannot decide it because you don't know the domain, right? That's why again a data scientist should be good business analyst. तो जब तक आपको डोमेन की नॉलेज नहीं होगी, आपको यही नहीं पता लगेगा कि मेरे लिए पॉजिटिव क्लास ज्यादा इंपॉर्टेंट है या नेगेटिव. और वो सब भी छोड़ो, हाइपोथेसिस बनाते समय क्या पॉजिटिव क्लास होनी चाहिए, क्या नेगेटिव क्लास होनी चाहिए, ये भी बात है. मतलब ऐसा नहीं है कि पॉजिटिव क्लास शुड बी कि ये बंदा फ्रॉड है और नेगेटिव क्लास है कि ये नॉन फ्रॉड है, ऐसा नहीं है. मतलब जब आप पॉजिटिव क्लास बनाते हो और नेगेटिव क्लास मतलब आप डिसाइड करते हो, तो नॉर्मली लोग सोचते हैं कि प्रिडिक्टिंग अ फ्रॉड इज पॉजिटिव एंड नॉट प्रिडिक्टिंग अ फ्रॉड इज नेगेटिव. ऐसा नहीं है. It can be reversed also, that my positive class is non-fraud and negative class is fraud. Okay. It all depends on what you want. In the current data set, it may so happen that cancer, predicting a cancer is positive. Okay. I'm just telling you that. Don't go by the data for now. You say my positive is cancer and negative is non-cancer, right? and it can be vice versa also. Okay, because that's where then the question come कि ये 0 क्या represent कर रहा है और 1 क्या represent कर रहा है. Okay, so if I say 0 represent Cancer and 0 is my positive class, then this is positive. तो उसके लिए मुझे ये समझना होता है, हो सकता है R जो है वो 0 को आपकी नेगेटिव क्लास बताता है, लेकिन पाइथन 0 को पॉजिटिव क्लास बताता है. ये लैंग्वेज टू लैंग्वेज या टूल टू टूल चीजें बदल जाती हैं, इसलिए उन पे इतना आपको रटने की जरूरत नहीं है. जब आप उस मॉडल को इंप्लीमेंट कर रहे हो, आप उस प्लेटफॉर्म के बारे में आपको पता होना चाहिए. कोई प्लेटफॉर्म 0 को पॉजिटिव लेता है, कोई प्लेटफॉर्म 1 को पॉजिटिव लेता है, ठीक है. बट जब हम पाइथन की बात करेंगे तो वो हमें डिसाइड करना है, मतलब पाइथन या एसके लर्न किस चीज को पॉजिटिव लेता है, किसको नेगेटिव लेता है. ओके, बट वट यू शुड बी क्लियर अबाउट इज कि मेरी पॉजिटिव क्लास क्या है, मेरी नेगेटिव क्लास क्या है. और इवन आप चेंज कर सकते हो इसको. मान लो आपका मॉडल बाय डिफॉल्ट कैंसर को 0 रिप्रेजेंट कर रहा है, आप उसे चेंज कर सकते हो. लाइक आर में आप लोगों के पास एक चीज होती थी, आर में फैक्टर, या आर में देयर इज समथिंग नोन एज फैक्टर्स, राइट. और फैक्टर का आप ऑर्डर चेंज कर सकते हो. गाइज, एम आई राइट? डू यू नो दैट लाइक labels are there, right? In factors there are labels and you can change the label and positive चीज negative हो जाती है, negative चीज positive हो जाती है, right? Similarly that can be done here also. So that's why I am saying it all depends कि मैं किस चीज को positive class रखना चाहता हूँ, किस चीज को negative class रखना चाहता हूँ. Okay, तो अब बात ये आती है कि आखिर ओवरऑल मॉडल अच्छा है या नहीं, वो तो एक्यूरेसी से पता लग गया, लेकिन मेरा मॉडल पॉजिटिव क्लास पे अच्छा बिहेव कर रहा है या नेगेटिव पे अच्छा बिहेव कर रहा है, वो मुझे कौन बताएगा? वो बताएगा प्रिसीशन एंड रिकॉल. ओके, सो हाउ टू गेट दिस चार्ट? यू हैव something known as metric, and again the metric package has the classification report, where again you pass the actual and the predicted data, the actual data and the predicted data, and it plots you this chart. As I told you, we will go into this detail later, but just for initial level, this is your precision, this is your recall, this is the F1 score. Can anyone tell me what is F1 score, guys? Can anyone tell me what is the F1 score, or what is the formula for F1 score? How we calculate F1 score? No, very good, Nitika, very good. So F1 score is a harmonic mean between the precision and the recall. Okay, it's not a arithmetic mean, it is a harmonic mean. That's where your F1 score is. And F1 score का ये फायदा है कि अगर प्रिसीशन और रिकॉल दो अलग अलग इंडिकेटर हैं और आप एक कॉमन इंडिकेटर यूज करना चाहते हो टू कंपेयर टू मॉडल्स, क्योंकि ऐसा हो सकता है कि एक मॉडल का प्रिसीशन ज्यादा है लेकिन रिकॉल कम है, और दूसरे का रिकॉल कम है, प्रिसीशन ज्यादा है, और आप उन दोनों को कंपेयर करना चाहते हो. आई टेल यू गुलजार, 1 second. So harmonic mean, or rather the F1 score, is used to compare the models, but still precision and recall plays very important role based on your business problem. What is support? Support is simply the number of records that support that particular decision. For example, how many records belong to 0 class, how many records to first. So if you look here, you have 49 records, like 0th class, 46 plus 3, 49, and then 65 records that supports the Y, the 1, 0 and 1. Then there is this accuracy, which is this thing. Okay, the accuracy of the model. Okay, total 114 records. There is this micro average and the weighted average, which is again just using these values we calculate these averages. These are not much used, you can ignore it, but when we talk about it in detail, I'll explain. Another point that we will talk about is why the two entries, it should be 1. So what's the reason to split it by support? So we will talk about it, but for the time being, remember we are talking about precision and recall and the F1 score. Now let's talk about precision, recall and F1 score. Yeah, so misclassification rate, is there. One second. Where we talk about TPRs, FPRs, and all those things. One second. Yeah. So you were asking about harmonic mean, Gulzar. So harmonic mean is nothing but given the value A and B, you will say twice of AB upon A plus B. That is the simple formula. Okay. And the reason behind taking the harmonic mean is so that the weights are sort of cancelled out, as in if one is very high, it cancels out the weight because of some multiplications. Because if you say A plus B by 2, here you are not cancelling the weights, as in one of them can be very heavily dominating the result. So you want to normalize it. So that's why we talk about harmonic mean. But you can read more about arithmetic mean versus harmonic mean. So the reason behind harmonic mean is sort of balancing the overall impact of the things, so that one of them is not dominating the final output. Like if your precision is too high but recall is too low, still that's not good, right? You want to balance it by numerator denominator में दोनों चीजें अगर आ जाती हैं आपकी. So read more about it. Yeah, Nishtha, support for the predictions, like कितने 0 predictions को support कर रहे हैं, कितने 1 prediction को support कर रहे हैं. Okay. Now the question is what is precision and what is recall. तो जैसे किसी भी mathematical experiment में होता है, precision as in कि वो tool कितना accurately चीजें predict कर रहा है, और recall as in उसको याद रखने की कितनी क्षमता है, as in previous उसने कोई operation किया था, वो उसको रिकॉल कर पा रहे कि नहीं, उसको सही से दोबारा से कर पा रहे कि नहीं. बट इसको प्रॉपरली अगर आपको समझना है, लेट्स गो बैक टू समथिंग. एक चीज है, अलग अलग वेबसाइट्स पे आपको अलग अलग चार्ट्स मिलेंगे. मतलब एक्चुअल यहां पर भी है, प्रिडिक्टेड यहां पर भी है, बट इसने नेगेटिव एंड पॉजिटिव किया हुआ है. मैं आई ऑलवेज टेक पॉजिटिव एंड नेगेटिव, लाइक पॉजिटिव ऊपर नेगेटिव नीचे. तो उस हिसाब से आपके ट्रू पॉजिटिव ट्रू नेगेटिव ये सब की रिप्रेजेंटेशंस बदल जाती हैं. जैसे कई लोग हमेशा सोचते हैं कि दिस सेल विल बी ट्रू पॉजिटिव, बट देखो इसका केस में ये ट्रू नेगेटिव है और ये ट्रू पॉजिटिव है. चीजें बदल गई, बट स्टिल मैट्रिक्स नहीं बदलेंगे, मैट्रिक्स अभी भी वही रहेंगे, आपके सेम रहेंगे. बट मेरा कहने का मतलब है किसी किसी वेबसाइट पे तो इवन आपको ये दिखेगा कि इस साइड पे प्रिडिक्टेड वैल्यूज हैं, इस साइड पे एक्चुअल वैल्यूज हैं. तो अगर आप सबके हिसाब से पढ़ने जाओगे तो आप कभी भी कॉन्सेप्ट बिल्ड नहीं कर पाओगे. तो अपने एक कॉन्सेप्ट बना लो कि मैं हमेशा इसी को फॉलो करूंगा, वरना ये कंफ्यूजन मैट्रिक्स हमेशा कंफ्यूजन ही रहेगा. सो ऑलवेज व्हाट आई प्रेफर इज प्रिडिक्टेड, ऊपर पॉजिटिव नीचे नेगेटिव, एक्चुअल, sorry, let me revert it. Actual, what I follow is actual, positive, negative, and on this side predicted, positive, negative. आप लोग अपना कोई एक कॉन्सेप्ट रख सकते हो जो आपको समझ आए, बट सिर्फ एक ही रखना. डोंट चेंज योर कॉन्सेप्ट बाय वेबसाइट्स और बुक्स just to build this confusion matrix. That's the only point. Rest everything is same. If I talk about accuracy, it's total जो सही predictions है, true positive true negative by total. Misclassification rate मतलब कितना आपने गलतियां की, which is for type 1 error plus type 2 error divided by the total. So if you see the accuracy of the model is 91 and the remaining 9% it's having the error, so that's even also known as error rate or the misclassification rate. Rest I think you guys are already aware about. These are very simple things like true positive rate, as in true positive जो आपने predict किए, excuse me, divided by the total actuals. Okay, so what do you mean by that is 105 मेरे थे टोटल मान लो कैंसरस पेशेंट्स, जिनमें से मैंने 100 को बता दिया कि तुम्हें कैंसर है, तो मतलब अब देखो एक्यूरेसी वाज 91 बट ट्रू पॉजिटिव रेट इज 95, so I may be happy because to me this is more important based on my problem statement. So true positive rate is also known as recall or sensitivity. How sensitive your model is towards the positive class, that's the sensitivity, okay, or the recall. So ये फॉर्मूले हैं, इनको जितनी बार पढ़ोगे उतनी बार इसमें कुछ नया ही दिखेगा, इनको सबको याद रखने की जरूरत नहीं है, just remember the concept behind them. So there is this true positive rate and then the true negative rate. This is important, okay. So these two things I always keep as important, true positive rate and the true negative rate. So ट्रू पॉजिटिव रेट जहां आपकी पॉजिटिव क्लास के बारे में बात कर रहा है, वहीं ट्रू नेगेटिव रेट आपकी नेगेटिव क्लास के बारे में बात कर रहा है कि आखिर नेगेटिव क्लास को कितने अच्छे से आप प्रिडिक्ट कर पा रहे हो. 83, दो इट्स नॉट गुड, राइट, इट्स नॉट दैट गुड, बट आई टोल्ड यू माई पर्पज इज बीइंग सेंसिटिव. स्पेसिफिक नहीं है मेरा मॉडल, मॉडल की स्पेसिफिसिटी में गड़बड़ है. स्पेसिफिक नहीं है से मतलब क्या है कि when it actually says no, how often does it predict no? Like similar, ये पॉजिटिव क्लास की बात हो रही है नेगेटिव की, बस उनको अलग अलग नाम दे दिए गए हैं. इसको हम सेंसिटिविटी या रिकॉल कह रहे हैं और इसको हम स्पेसिफिसिटी कह रहे हैं, बट बोथ आर इक्वली इंपॉर्टेंट, ओके. एंड द लास्ट वन इज after the TPR and the TNR, the sensitivity and the specificity, the only thing that left is precision. Precision is in, जैसे हम कहते हैं कि आपका कोई भी डिवाइस है वो कितना प्रिसाइज कैलकुलेशंस कर रहा है, कैलकुलेटर भी कितना प्रिसाइज है, फॉर एग्जांपल. तो what do you mean by that is you predicted some things as yes, right? You predicted certain things as yes, like तुमने इतने लोगों को बोला भैया तुम्हें कैंसर है, लेकिन उनमें से कितनों को असली में था? जितनों को तुमने बोला उसमें से असली में कितनों को था? ये अपने आप में एक और इंपॉर्टेंट पैरामीटर है, वो मेरे पास है 91. तो ये सारी चीजें सुनने में बड़ी सिमिलर सी लगती हैं, इसीलिए दिस इज लाइक कंफ्यूजन मैट्रिक्स. आई एम अगेन टेलिंग यू कि एक्यूरेसी भी वही चीज है, प्रिसीजन भी वही चीज है, ट्रू पॉजिटिव रेट भी वही चीज है, but there are slight differences which we are talking about. Accuracy is talking about the overall thing, whether it's true positive or the true negative, whereas true positive is specifically talking about the positive class and the true negative as well, whereas precision is specifically talking about the positive class but in a different way, okay. Don't do with this, as there are a lot like prevalence and all. No need to do all those things. The only important thing that you can be asked in interviews is accuracy, misclassification rate, ROC, AOC. That's one cluster of things. The another group of things that can be asked is TPR and TNR, true positive and the true negative rates, कि पॉजिटिव क्लास और नेगेटिव क्लास में मैं कैसा बिहेव कर रहा हूं, विच इज लाइक सेंसिटिविटी एंड स्पेसिफिसिटी, एंड फाइनली द प्रिसीजन. सो दिस formulas at least you should remember, but if you forget, it's not that important, but let's try to remember them. We will keep talking about this in each and every classification model that we do, okay. So here he is talking about the ROC curve, so you guys can read about it, what the ROC curve is, and like what is F score is. F score is like a weighted mean. It's like a weighted mean or harmonic mean. Yeah, Anam.
Oh, sir.
One second. Anam, the answer to your question is, it's the predicted yes, right? So how much you predicted. So whether it's a true positive or a false positive, it is that you are predicting those. So true, absolutely. It's TP upon TP plus FP. Absolutely correct. Yes.
Sir, is it necessary that जो हमारे target variable है, that is to be classified, it has to be in the form of 0 and 1? Like if it's a yes and no in place of that will also work.
So that's the problem with sklearn. The target needs to be in 0 and 1. So what I mean to say, 1 second. Anam, 1 second. Let me clarify that. Wait. Yeah. So the question that someone was asking, see, in R, I think R still allow you to pass like values as positive, negative, true, false, fraud, non-fraud, cancel, non-fraud, maybe. But sklearn, you need to label and code it in 0 and 1. That's what you have to do. Okay. So you have to convert it in zeros and ones, the target classifier. Okay. Okay. Coming back to your question, Anam, 1 second. So where is it? So let's go back to this. Okay. So Anam, if you see what I'm talking about is predicted yes, right? So it's FP plus TP, right? I think what you pinged lastly was wrong. Okay. Oh, okay, okay. I got it, Anam. I think you were answering Gulzar. Okay, okay. Oh, no problem. Okay, okay. Got it. No problem. Thanks a lot, Anam. Okay, okay. So wait, guys. Okay, so guys, we'll take a 15 minutes break. The things started a bit late today, but yeah, take a 15 minutes break and then we'll be back at 11:45 and then we'll continue from here. I'll first talk about some models, maybe some basics about the SVM or the KNN, and then move on to the naive bias. Just to see how much you are clear on the SVMs and the KNNs, and then we'll move forward. Okay, so let's connect at 11:45. There is some power cut. Please let me know if I'm audible. Okay, perfect. So I'm just connecting to some other network. Just let me know if my screen is visible as well. Okay, perfect. Thanks. So we'll guys, we'll proceed ahead now. So what we are talking about is the classification models, where there is a specific EDA where we talk about class imbalancing, undersampling, oversampling. Then we implement the model and the evaluation. Okay, so that's all we talked about. One second. Yeah. So now what we are going to study is after the logistic regression, the another linear model of classification, which is support vector machine. Support vector machine, yeah, I know you guys have done, but since some of you are asking, I'm just going through very basic stuff just to revise the things for you. So how the support vector machine basically works is, we talk about three things here. We talk about support, we talk about the vector, and we talk about the machine. Okay, so ultimately we know that what are support vectors. Support vectors are those data points which helps me to identify the margins, right? So if you look at this image over here, so I have plotted this data. Okay, this is my data, say, which is plotted based on two features, X and Y, and then color coding is done, like blue color or black color is the negative class and the red one is the positive class. And then this is the hyperplane. But what I want is, I want the margins, the M1 and the M2, because it's a constrained optimization problem or the maximum margin optimization problem. And this width is known as your gutter width or the street width. इसको हम street भी कहते हैं कि this is a street or a gutter, so it's like a street width or a gutter width. So there are three hyperplanes. One is the main hyperplane and two marginal planes. We know the support vectors. Support vectors are the ones which are lying on the marginal planes, right? Positive margin and the negative margin. Marginal distance, like distance between one margin with the hyperplane and another margin with the hyperplane, these are marginal distance. Linearly separable. So definitely your data can either be linearly separable or non-linearly separable. So if data is linearly separable, we talk about linear kernel. If it is non-linearly separable, we talk about RBF, radial basis kernel, or maybe polynomial kernel. Different kinds of kernels. Kernels are nothing but maths, the mathematical formula which helps you to just understand the data which is projected in a higher dimension. Okay. So again, support vector machine is yeah. So again, the support vector machine has its own mathematical formula, which is also a linear regression formula, which is like y is equal to mx plus c, because here also it's like a line or a hyperplane. But as I told you, here y is equal to mx plus c does not work. Rather, we need to convert that into a matrix form, which is y is equal to the wt into x plus b, where what is this wt? This wt is the transpose of the weight vector. What I mean by that is, say, again, you have weight m1 comma weight m2, right? This is your weight vector. Transpose of a vector converts it from horizontal to vertical. It's like m1 here and m2 here. So transpose of this matrix is this, and transpose of this matrix is this. Okay, it's like transpose. So if my weights were like -1 and 0, okay, the transpose of that will be represented like this. So this is the WT. So if this is the weight vector, this is the WT vector, the transpose of the weight vector. And this is your feature vector. Feature vector as in the feature values. So if you have two features like age and salary, so say isko plus kar do, say 4 is the age and say 0 is the salary. So this is the feature vector. Okay. So this is how we represent it. And then we multiply these two. But this multiplication is a matrix multiplication. And how the matrix multiplication works is, Gunja, don't go into that, because why can't you have a 0 salary? If someone is having a age 4, he can have a 0 salary, right? And still you want to predict something for him, right? So the point is, the matrix multiplication works in, like, first you go horizontal and then you go vertical in the downstream. So what I mean by that is, this multiplied by this, let me explain you. 1 second. सो अल्टीमेटली उस मैट्रिक्स फॉर्म को मैं लीनियर फॉर्म में कन्वर्ट करके ही दिखाने वाला हूं आपको कि हाउ यू नॉर्मली थिंक द डेटा इज. Okay. Yeah, I think this is better. Yeah, so let's see. So if this is one metric, this is another metric. Okay. So how you will do is, you go in this direction, and for this metric you go in this direction. That means this value multiplied by this value plus this multiplied by this plus this multiplied by this gives you the C1. So even if you look here, 1 multiplied by this, yeah, this is matrix multiplication. This multiplied by this multiplied by this is giving you this value. Okay. So it's like this with this is first one. Then this with this will be this one. Then this value multiplied by this will give you this. Okay. So this is how it works. So this is matrix multiplication. So let's go back to this thing. So here what will be the output is, again, this will be multiplied by this value. There is nothing to go down, so it's like both of these will be multiplied. There is another concept behind matrix multiplication कि dimension. इसके dimension क्या है? It's like rows into columns. इसमें कितनी rows है? 2. Right? There are 2 rows and 1 column. Right? इसमें 1 row and 2 columns. Right? So the resultant of this multiplication will be, I think 1 by 2. Let me just check. Can anyone tell me 1 by 2 or 2 by 2? 2 by 2, Pragesha. Okay. Yeah, correct. So number of rows of this and number of columns of this, right? So we'll take number of rows from here, number of columns from here. So that means I need to get 1, 2, 3 and 4 values out of it, for example. So this will be multiplied by this. I will get 4 here. Guys, please correct me if I'm going wrong. Okay. This multiplied by this, then this multiplied by this, here it will be 0. This multiplied by this will be 0, and this multiplied by 0, which is 0. So this is what the output will be. Okay. So that means 2 by 2 is the output, 2 rows and 2 column. तो ये हमारा एक matrix operation यहाँ है, which we can think about. So this is the final output of from this. So the whole concept behind the SVM is, first you represent your weight vector as like weights as a weight vector, do a transpose, and features as like a feature vector without any transpose. You multiply those to actually come out to the final value. Even this guy is getting the value as 4, right? So the output that is getting predicted is 4. Okay. But if you have values for other fields also, then you have to take a determinant of a metric. So if you get values in other fields also, we have to get the determinant of a metric. Okay. Yeah, Nishta, but here we are interested in this particular value which is coming out. Okay. So we can also take determinant provided if we have the other values, else this value is enough to represent the output for me. Okay. So what happens here is, first of all, you should understand the matrix operations, and then you can better understand this in detail. Here this intercept is 0 because here we are showing that hyperplane is passing through the center. Okay. Using this detailed calculation, we can do the derivation definitely. Again, not going much detailed, but if you see, I was telling you, right, the norm of a vector means we have to use norm of a vector at multiple places, especially when we talk about logistic regression or maybe a support vector machine, that kind of algorithms, to build our optimization function. So here, if you just have a look, again, you guys can read more about these things. But here, if you see the optimization function, yeah, so this was the optimization function actually. This was the optimization function, and my purpose was to maximize it. The arrows up arrows here signifies I need to optimize it and maximize it. Okay, maximize it. But you can convert this function in the reverse order. Like if you can just say like this, if I only need to calculate this value, my purpose or objective is to minimize this value. Because if I minimize this value, automatically this thing will be maximized, right? Guys, getting it? अगर डिनोमिनेटर को आप मिनिमाइज कर दोगे तो इक्वेशन अपने आप मैक्सिमाइज हो जाएगी, करेक्ट? तो इसीलिए ये है तो एक मैक्सिमाइज्ड इक्वेशन, एक मैक्सिमम मार्जिन इक्वेशन, लेकिन व्हाट this person did here is converted it into minimization problem by taking this value in the numerator. Just उसको reciprocate कर दिया, 2 by norm को norm by 2 कर दिया. So sometimes it happens that you will see that Rahul told it's a maximization problem, but you will read somewhere on the internet that he's solving it is in a minimization way. Then you should understand that both are possible. It's just the formula will get reversed. Okay. 4 times plus Gulzar Nishta person. What is 4 times plus? Okay. Okay. 1 second, guys. Okay. Yeah. So this is what I was like just wanted to tell you. लाइक जब आप लोग सपोर्ट वेक्टर मशीन को डिटेल में अगर पढ़ोगे तो सपोर्ट वेक्टर मशीन नॉर्मली टॉक्स अबाउट द मैक्सिमम मार्जिन ऑप्टिमाइजेशन प्रॉब्लम, जहां पर आपको मार्जिन को मैक्सिमाइज करना है, बट उसको आप एक मिनिमाइजेशन प्रॉब्लम में कन्वर्ट कर सकते हो. दैट्स व्हाट इज बीइंग शोन हियर. And plus this additional part which is here is some additional error term which is being added to this particular support vector machine. So there is a whole reason behind it. Again, not going into that, but this is something additional which gets added into the model. Okay, this is something quite interesting, which is again support vector machine, but an MIT lecture. So where again they are talking about the support vector machines, one of the most important models in the classification. Here the approach is the widest street approach or the gutter length approach. Okay, so what happens is it's the widest street approach, and then there are certain kernel functions that we normally talk about, and decision boundaries, as in when you have to segregate the classes, you have decision boundaries, nothing else. So here what this guy is trying to do is what I told you yesterday also, is for example on this chart, I plotted a point, right? Say these all crosses are nothing but the points, and say this is one point, guys, and this is say another point. Okay, now what I want is I want the width of this street. It's not possible for me to directly get the width of the street, right? That's where the support vector helps me. So if this is support vector for this margin, and this is the support vector for this margin, if I can create a vector and I know its magnitude, and if I create this vector and I know its magnitude, and as I told you, I can calculate the distance between these two vectors, right? So that will give me the width of the street. So it's all vector algebra and the matrix multiplications. So here if you see, this is the vector for one margin, this is the vector for another margin, and this dot is actually the dot product. In the field of vector, there are two things, cross product and dot product. Okay, so you can read about it. Like in matrix, we have matrix multiplication. In vectors, we have the dot product and the cross product. So this is what. So कभी भी किसी वर्ड के ऊपर अगर एरो लिखी है मतलब वो वेक्टर्स है, और तब उनके पास जो मल्टीप्लिकेशन है ये डॉट प्रोडक्ट है, अगर अदरवाइज इट कैन बी अ क्रॉस प्रोडक्ट. There is a reason behind this dot product. It's like the magnitudes of the vectors, multiplied by, I think, sine theta. Someone can correct me if that's not right. Sometimes I also forget. So dot product between two vectors is the weight of the two vectors or the magnitude multiplied by sine of the angle between the two, which is, this is the angle that they create with each other, right? So if I know the theta, I can get okay, Nishtha, thanks. So yeah. So definitely, so it's cos theta. So that's why you don't need to remember all formula, but yeah, always refer some documents always. So this is what the dot product is. Then you have cross product also. So it's just sine theta or cos theta. That's what this represents. Then further derivation goes on. This is what's happening, which I was telling you. Just subtraction of the two vectors. This is where the equation is getting built. The width of the gutter is being built. The width of the gutter, which is one vector subtracted with the other vector, and ultimately you get to that equation. जो ऊपर वाले बंदे ने explain किया था, उसने अलग approach लेके यहाँ तक reach out किया था. इसने अलग, MIT वाला है, इसका अलग approach है, but they are reaching to the same conclusion. And now the purpose is to maximize this value or minimize the reverse of it, which is this divided by 2. So whichever way you can go. So if you look finally, ऊपर भी एक इक्वेशन बननी थी, यहाँ पर भी एक इक्वेशन की बात हो रही है, जो फाइनल ऑप्टिमाइजेशन इक्वेशन है. इसने भी वही किया है, नॉर्म ऑफ द वेक्टर को डिवाइड बाय 2 कर दिया, मतलब मैक्सिमाइजेशन प्रॉब्लम को मिनिमाइजेशन प्रॉब्लम में कन्वर्ट कर दिया. ठीक है, इस स्क्वायर को अभी के लिए इग्नोर करो। एंड दिस एडिशनल पार्ट जो ऊपर आपने देखी थी उसने भी कुछ एरर टर्म ऐड की थी, इसने भी एरर टर्म ऐड की है। ये जो एडिशनल एरर टर्म है दैट इज नोन एज द Lagrange's multiplier, or this is the entire minimization equation where this is the Lagrange's multiplier part. So in support vector machine, this Lagrange multiplier is something which is important, or this equation which is something important. There are multiple ways to reach out to it, but this is what I was telling you. जैसे कि logistic regression में there is something known as sigmoid functions and Hessian metrics. Here you have Lagrange's multiplier. ये सारी चीज कॉमन है, बट ये वाला जो पार्ट है द एडिशनल एरर पार्ट, जिसमें ये अल्फा पार्ट जो है ये Lagrange's multiplier टर्म है। तो यू कैन रीड थ्रू दिस, ये टोटल एरर है, प्रेडिक्शन एरर मॉडल की। ओके, सो these are some basics. You can read more about it, go through my GitHub documents. But now the bigger question that I have is, one second. Sorry, yeah. So the bigger question now that comes is that both of the linear models that we talked about, the logistic regression and the support vector machine, they does not support multi-class classification. Okay, they are built only for binary class classification. However, there are some enhancements which are done to make them support the multi-class classification, but natively they don't support it. So the enhancements that are done are known as OVR and OVO. So guys, are you aware about OVR and OVO? If yes, we can leave it. Guys, OVR and OVO. Okay. One second. Okay, I'm pinging you a link. You can refer to this as well, but let me explain you. One second. Okay, so this is one of the most important thing from the interview point of view and from the practical project work, the OVR and the OVO, because you normally face multi-class classification in real world. So you have to do this. Like you have to predict 3 categories of your customers. One is say the maybe the best customers or the most frequent customers. One are the least frequent, and one are like the average who visits your website. Okay, or maybe such kind of other categories you want to divide your customers in. Okay, for example, even Netflix, they want to categorize their customers into certain known categories, more than 2 categories. Okay, in all such cases we go with multi-class classification. So and to do that we have OVR and OVO. So what this says is OVR is like one versus rest. मतलब मान लो आपको 3 क्लासेस प्रिडिक्ट करनी है, you have to predict 3 classes. So one versus rest will say you will predict for this, but consider both of these as one single group. One versus rest. Okay, तुम्हें बाकियों से मतलब नहीं है, तुम बस ये देखना चाहोगे कि क्या वो इस क्लास को बिलोंग करता है या नहीं। अगर नहीं करता है तो वो इनमें से किसी को बिलोंग करता होगा, वो बात की बात है, बट पहले मैं सिर्फ ये देखूंगा क्या वो इसको बिलोंग करता है, या तो ये या फिर कुछ और में बहुत सारी चीजें हो सकती हैं। तो इट विल से यू हैव 3 classes A, B and C. So it will create first logistic regression or SVM model, like this is class, this is one class and this is another class, but this internally contains 2 classes. Model will not worry about that. उसके लिए both of these will be part of one class. But then another model will be executed where B is 1 and A and C are rest. Similarly, another model will be run C and A and B are the part of another cluster. So that way, if I am implementing a logistic regression and specifying that it's a multi-class classification with OVR, internally it will run 3 logistic regression models, guys, like this, taking each class as the main thing. This is not a backend test, like it's not like grid search CV. It's something that happens automatically, but it's a model. So it's actually a meta model, as I told you, right? OVR and OVO are meta models. So if you say that you want to run OVR and you contain 3 classes, so ultimately 3 logistic regression will be run internally. You will not see it. Model will run it, and it will give you the output. If you want, you can see that, but there are some additional things you have to do. But remember, this is what you can do. So the number of models that gets created is equal to the number of classes. Okay. And say, for example, you pass on a record and you want to predict कि भाई ये किसको belong करता है. So it will go here and some probability will come that it belongs to this or this. Some probability will come for this, some probability will come for this. So ultimately we take the sum of the probabilities or the max of the probabilities, not sum, but max of the probabilities, like argmax. I was telling you, right, argmax yesterday. तो इन तीनों में से वो किसको बिलोंग कर रहा है, मतलब यहाँ पर उसकी कुछ प्रोबेबिलिटी आएगी, यहाँ पर तो हम argmax ले लेते हैं. So if you see here, if you have 3 classes, you have to predict the color, whether it's red, green or blue. So one will try to predict whether it's red or rest, whether it's blue or rest, whether it's green or rest. You will get probabilities for each one of these. So this approach requires that each model predicts a class membership probability or a probability score, and we take the argmax. इनमें से जिसका max score आया, it belongs to that. The one with the largest score will be given by the argmax, the index, right? Like 0, 1 and 2. We were talking yesterday. So that's what this do. But the problem with this model is it will be slow because it is running 3 models instead of 1 single model. So that's the problem. Here we get 3 binary models. So 3 binary classification models will be created actually if you have 3 records. So that's 1 versus rest. Then there is 1 versus 1. So what it do is, it's more complicated. It says if again you have A, B and C, 3 classes to predict, you will create the combination, all the possible, say, permutations, and that many models will be there. The permutations, it's something like, I think 3P2 or 3C2. Permutations or combinations, 1 second. Which one does not take care of the order, guys? Like A and B and B and A are same in both, in which permutation or combination? Please tell me. A, B and BA are same for what? Permutation or combination? Very good. Okay. Guys, anyone else has different opinion? Is it permutation or combination? Guys, if no idea, please ping me no. Okay. Other people, please, they want to try. Order does not matter in which permutation and or combination. Okay, no problem. Read it. Okay, this is an assignment for you. Okay, this is an assignment for you. But also read the formulas for permutation and combinations. Yeah, Rahul. Thanks. Yeah. So permutation order matters and combination order does not matter, right? And the formulas are also different, right? Like NP2. Say if you have say 3P2, 3P2, and they have 3C2. So this is formula for permutation and this is for combination. 3P2 is like 3 factorial upon I think 2 factorial, and 1 second, and combination is like 3 factorial upon say 2 factorial into 3 minus 2 factorial, which is like 1 factorial. Okay, permutation order matters, so there should be more. Guys, is it correct? Again, those who know 3 factorial upon 2 factorial and 3 minus 2 factorial. Yeah, this is what 3 factorial upon 2 factorial, 3 minus 2 factorial. This is for combination, and for permutation it is what? 3 factorial upon 3 minus of 2 factorial. Okay, so I'll tell you, those who don't know about this, guys, these things are important. Okay, 1 second. So the permutation combination is used heavily in the field of gambling, in the field of probabilities. Okay, and these questions आप लोगों ने अगर किसी ने मतलब MBA वगैरह दिया हो तो they have to read a lot about this. So if you see, guys, so permutation, like if I say 3P2, so here 3 is N and 2 is R. So the formula is N factorial upon N minus R factorial, as a few of you are telling me, which is 3 factorial upon 3 minus of 2, which is 1 factorial. Okay, which is like 1 factorial, and the value output will be 3 factorial is what? 3 multiplied by 2 multiplied by 1 upon 1 factorial is 1. So the output is 6, right? Yeah, perfect. So similarly the combination is this. तो अगर आप देखोगे कॉम्बिनेशन में एक एडिशनल पैरामीटर नीचे डिनोमिनेटर में आ जाता है, तो दैट मीन्स कॉम्बिनेशंस की वैल्यू हमेशा परम्यूटेशन से कम होंगी. परम्यूटेशंस ज्यादा होती हैं, कॉम्बिनेशंस कम होती हैं. तो सीधा सीधा मतलब है कि कॉम्बिनेशन में ऑर्डर जो है वो मैटर नहीं करता. ए बी एंड बी ए दोनों सेम होते हैं, जबकि परम्यूटेशन में ऐसा नहीं है. तो रीड अबाउट परम्यूटेशंस एंड कॉम्बिनेशंस. Again, these things will come handy at multiple places. So here in 1 versus 1, what happens is, जितनी आपकी क्लास है उनके जितने भी पॉसिबल ग्रुप्स यहाँ बनेंगे, लाइक रेड ब्लू. अब रेड ब्लू या ब्लू रेड एक ही बात है. तो व्हाट इट इज गाइस? परम्यूटेशन और कॉम्बिनेशन. रेड ब्लू एंड ब्लू रेड इज सेम, सो इट्स परम्यूटेशन और कॉम्बिनेशन. Combination. Very good. So here, if you apply the combination formula, you can get that given n number of classes, how many models internally will be built. So, or there is a simpler formula which is k into k minus of 2 by k minus of 1 by 2. Put the classes here. So if you have 6 classes, so 6 into 5, which is 30 divided by 2, which is 15. 15 models will be executed. Okay, so 1 versus 1 is like this, where it creates multiple models. As is, you have to predict red and blue, red and green, red with yellow, then blue with green, blue with yellow, yellow with green. It for a given record, it gets the probabilities for all, and then we calculate the sum of the probabilities. So here the approach is different. here we get the sum of the probabilities to get to that result. 1 second. Okay, you can go through this link more. We are already over the time, but another thing is how to tell your model, like whether it's logistic regression or support vector machine, whether you are facing a multi-class classification problem, and whether you want to do OVR or OVO. So there is something known as decision function shape. You can just pass that as OVO and OVR. Let me show you that. 1 second, guys. Okay. So where is the logistic regression model? So if I go, so that's why the hyperparameters are important for any model. That's where you can play with it. So let me just check in the logistic regression. So I'll check the logistic regression, what it will do. Okay. So in logistic regression, do we have the decision boundary? Yeah. So if you see, there is this option, guys, multi-class. So this multi-class option here, either you can say auto, you can put OVR, okay, and multinomial. So these are like the place where you can change it. And if you want to see what internally happens, you can go back to the site packages and see how model will work when the value is OVR. Here also, I think it must be given OVR, OVO, whatever, 1 versus 1, 1 versus this. So for that, you have to check whether that model supports that particular value and in which way it supports. For example, I cannot see OVO there like you guys, so then I have to check क्या multinomial में वो OVO वाला ही काम कर रहा है या नहीं, तो वो मुझे देखना पड़ेगा यहाँ पे, because Python, R, SAS हर किसी का तरीका अलग होता है चीजों को डिफाइन करने का, ठीक है, तो वो आप देख सकते हो, बट व्हाट आई एम टेलिंग यू इज दिस इज वेयर यू चेंज दिस OVOs and OVR. Let me show you in the support vector machine now. One second. I think some problem is happening with this notebook. It's not opening these things. So what I'll do, I'll immediately do something else. Import site dot get site packages. ओके, सॉरी सॉरी, इट्स ओपनिंग एक्चुअली, मैंने उसको नीचे कर दिया था तो मुझे वो दिख नहीं रहा था। या राहुल, करेक्ट करेक्ट, थैंक्स। या सो इन द लीनियर एसवीसी अगेन, लाइक आपके पास वही पेनल्टी पैरामीटर्स हैं, लॉस लाइक हिंज लॉस, स्क्वायर हिंज लॉस, किस लॉस की आप बात करते हो? हाँ, अब यहाँ अगर आप देखोगे मल्टी क्लास में वही ओवीओ, ओवीआर, क्रैमर सिंगर, अब ये और अलग अलग अप्रोचेज हैं। मेनली आप ओवीआर, ओवीआर पे, ओवीओ पे फोकस करो, यू डोंट नीड टू रीड अबाउट मोर। इफ यू आर इंटरेस्टेड आप पढ़ सकते हो, क्रैमर सिंगर इज अनदर अप्रोच। ओके, so this is the place where you can change it in the multi class. I don't understand what it was doing this thing. 1 second.
Sir?
1 second, 1 second. I think this is some old function maybe. Let me just check it. Why this guy is asking to put it in decision function shape, right? 1 minute. Okay. So as we know that even not different languages, rather different model packages, different packages have different ways of passing the value. So yeah, so this is another place, like here it's asking OVO and OVR in the decision function shape. But it all depends what you're trying to do, because here I was using linear SVC. So it may so happen that linear SVC might not support the another one, but we have to check that. However, this SVC, which is a generic formula for the even linear SVC, can also be done here by passing the kernel as linear. So you can use this also. So whichever you use, just know what is the purpose of that hyperparameter. Yeah, someone having a question. Yeah.
सर, सो ये OBO and OBR एक हाइपर पैरामीटर है, तो हम इसे कहाँ मेंशन करेंगे सर कि हमने ये वाला टेस्ट करना है?
हाँ, तो मैं वही बता रहा हूँ ना, ये एक देखो, ये हाइपर पैरामीटर है भी और नहीं भी, बिकॉज सी हाइपर पैरामीटर आइडली वो होता है, आइडियली जो आपके मैथमेटिकल फॉर्मूले को इम्पैक्ट करता है, जो एल्गोरिथम में जाके सीधा हिट करता है. And that's why in the very first class I told that there are two things, parameters and hyperparameters. Some things are only parameters, not hyperparameters. So passing the OVOs and OVRs, you can say hyperparameter, but actually it's not a hyperparameter, it's a parameter. Okay, so because it just decide that how many models should run. ठीक है, कि भाई आपके 5 लॉजिस्टिक रिग्रेशन चल रहे हैं या 6 चल रहे हैं बिकॉज ऑफ OVO और OVR, बट वो 5 मॉडल इंटरनली कैसे चल रहे हैं, उस चीज को जो इंपैक्ट करे वो हाइपर पैरामीटर होगा, जैसे रेगुलराइजेशन स्ट्रेंथ, द सॉल्वर. ठीक है, तो दैट्स द डिफरेंस बिटवीन द पैरामीटर एंड द हाइपर पैरामीटर. तो OVO OVR को आप अगर इंटरव्यू में कोई पूछता है तो बोल सकते हो कि ये भी पैरामीटर्स हैं, बट स्पेसिफाई कर देना. अगर वो हाइपर पैरामीटर पूछ रहा है तो बोल देना इनके बारे में भी, बट स्पेसिफाई कर देना कि ये हाइपर पैरामीटर नहीं है, रादर ये पैरामीटर है, बिकॉज ये मॉडल को नहीं मेटा मॉडल को इंपैक्ट करते हैं. समझ रहे हो? वी आर टॉकिंग अबाउट मल्टीपल टेक्निकल जार्गन्स, कि भाई कौन सी जो चीज आपके मॉडल को सीधा सीधा इंपैक्ट कर रही है या मॉडल के एल्गो को, वो है आपका हाइपर पैरामीटर. लेकिन जो मेटा मॉडल को इंपैक्ट कर रही है वो एक सीधा सीधा पैरामीटर है, वो हाइपर पैरामीटर की कैटेगरी में नहीं आएगा. बट इंटरव्यू में कई बार इंटरव्यूअर को भी नहीं पता होता, टू बी वेरी फ्रैंक. तो वो सोच रहा होता है कि आप OVR बोलो और आप नहीं बोल रहे क्योंकि आपको लग रहा है वो हाइपर पैरामीटर नहीं है, तो वहां आपकी गलती है। आप बोल दो बट उसको एक्सप्लेन कर दो, ठीक है, अंडरस्टैंड दिस थिंग। जैसे एन जॉब्स है, कल हमने जो एन जॉब्स इसको पैरेलल में रन करने के लिए हमने दो चीजें सेटअप की थी। जैसे वर्बोज है, वर्बोज एक पैरामीटर है, हाइपर पैरामीटर नहीं है, बिकॉज ये सिर्फ ये प्रिंट करता है कि मॉडल पीछे चल कैसे रहा है। एन जॉब्स ये भी एक तरह का पैरामीटर है, बिकॉज ये बता रहा है कि मॉडल पैरेलली आपके कितने कोर्स को यूज कर सकता है। ये आपकी इक्वेशन को चेंज नहीं कर रहे हैं, पीछे की फॉर्मूले को चेंज नहीं कर रहे हैं, बट सागा, पेनल्टी, मैक्सिमम आइटरेशंस, रैंडम स्टेट, सी, ये सब हाइपर पैरामीटर्स हैं। ओके ओके, सो वी टॉक्ड अबाउट द सपोर्ट वेक्टर मशीन एट लीस्ट अ बिट, लाइक कि भाई देखो उसमें जो मैक्सिमम मार्जिन प्रॉब्लम है वो क्या है, उसका मैक्सिमाइजेशन फॉर्मूला क्या है, मिनिमाइजेशन फॉर्मूला क्या है, और उसमें लैग्रेंजेस पार्ट जोड़ के उसको लैग्रेंजेस मल्टीप्लायर जोड़ दिया जाता है जो फाइनल फॉर्मूला होता है एरर टर्म के साथ, एंड उसको फिर फाइनली हम आगे प्रोसेस करते हैं। That's what it is. And then internally there are two things, OVR and OVO, which are very important for multi-class classification. Okay, but ये उन मॉडल्स के लिए है जो बाय डिफॉल्ट सपोर्ट नहीं करते बाइनरी चीज को, सॉरी मल्टी क्लास को, जैसे लॉजिस्टिक और एसवीएम। लेकिन अब हम नेक्स्ट कैटेगरी ऑफ मॉडल्स में मूव कर रहे हैं, वेयर वी टॉक अबाउट KNN, naive bias, or maybe decision trees. These models actually supports the multi-class classification, so you don't talk about OVR and OVO there. Okay, so OVR is being talked in these two places. Okay, and some other models like some neural networks, specifically perceptrons. I'm not talking about that right now, but yeah, so this was about it. So now moving to the another set of models, they by default supports the multi-class classification, so you don't need to worry about it, like KNN, naive bias and all. So I'm moving into the KNN first. There are some important things I would like to discuss here also, because we have already done it. So first of all, KNN is one of the very simple model, but it can be used for both classification and regression. Here the important things to know is K and NN, where K is the thing that you have to decide and N is the nearest neighbors who helps you to predict the output. Now my question is how to predict the best value of K. Can anyone tell me, whether you do regression or classification, how to predict the best value of K? Please, okay, anyone else? Guys, even if it's based on distance between the points. No. Grid search CV. Okay. Guys, go ahead. Let me put the charger meanwhile. I understand this is very simple model, but I want few answers. K is the square root of N. Okay. Cross variable. Okay. Is there a limit on the value of K? Someone is saying square root of N. Okay. Square root of data points. Okay. Keep pinging me. I'm just showing you that. Okay. So definitely we can talk about a K or the number of neighbors as based on the elbow method. That's one of the best way. Or for elbow method, we use grid search CV. Okay, so grid search CV can be used, or you can do it even without grid search CV. But yeah, grid search CV is one of the way where you can put multiple values of K and you will get the best value of K. Or you can plot a elbow curve. Okay, but the point is, yeah, Anam, K needs to be odd always, because if it's even, there are certain problems that you fall into. You won't be able to predict the actual value sometimes. So that's the point. Other than elbow, there is one more chart which is known as knee chart. Okay, so there are two charts, guys: elbow chart and the knee chart. Okay, so what is the difference? So you plot a chart. So the elbow chart is like this, like जैसा आपके हाथ का elbow रहता है, जैसे आपका elbow है इस तरह से. Okay, elbow chart, what it tells you is, with the increasing values of K, something is decreasing. And what is that something? Can anyone tell me? K की वैल्यू हम एल्बो चार्ट, नी चार्ट दोनों से निकाल सकते हैं, ग्रिड सर्च सीवी से भी निकाल सकते हैं. इसकी वैल्यू ऑड होनी चाहिए, करेक्ट. बट नाउ द पॉइंट इज, व्हाट इज दिस वैल्यू विच इज डिक्रीजिंग? एल्बो चार्ट में वाई एक्सिस पे क्या होता है? एक्यूरेसी डिक्रीज थोड़ी होनी चाहिए. With the increasing K, something should be decreasing, which is nothing but error, guys. Yeah, Anam, yes, Rahul. Error or WSS. WSS normally when you talk about K means clustering, तब आप WSS की बात करते हो within sum of squares, but it's fine. शायद आपने ये K means clustering में किया होगा WSS, but yeah, it's error which decreases. So there is this sweet point after which the decrease in the error is very minimal, because the more the value of K, the more computation power you have to put, और उतना ही ज्यादा टाइम लगेगा उस मॉडल को ट्रेन होने में. इसीलिए ऐसा नहीं है कि मैं K की वैल्यू हंड्रेड्स में ले लूं, बिकॉज उतना ज्यादा प्रॉब्लम हो जाएगा, स्लो हो जाएगा मेरा मॉडल. तो एक स्वीट पॉइंट है जिसके बाद एरर स्लोली डिक्रीज होती है, तो हम वहां जाके रुक जाते हैं. सो दैट्स एल्बो. नाउ व्हाट इज नी चार्ट? सो ऐसा कुछ नहीं है कि आपको एल्बो चार्ट ही बनाना है, आप नी चार्ट भी बना सकते हो. Knee chart is something like this, like the knee of your leg, right? With the increasing K, something increases. Now what is that, guys? Can you ping me? As you increase the K, what should increase? Yeah, correct. Now, yeah, so that's where the accuracy comes into picture. So if you're plotting K versus error, it is this. If you're plotting K versus accuracy, it is knee chart. And here also the same thing happens. Like initially you increase K, तो बहुत जल्दी बहुत high increase in accuracy, but after a particular point, a sweet point known as inflection point, you see that you're not gaining that much accuracy as compared to the computation power that you are losing, right? So you will stay at this value of K here. Okay, so these are the two charts. There is one more thing which is known as Silhouette curve or Silhouette chart. Read about it. I'm just writing it here. What is the Silhouette curve? That's the third thing. It is also used to get the K value of K, but mostly in the case of K means clustering. But this is one of the very important thing. What is the Silhouette curve from interview point of view? Okay, so read about all these three. प्लॉट करना उनको कोई बड़ी बात नहीं है, आप चाहे तो एरर को प्लॉट करो या एक्यूरेसी को प्लॉट करो. इन्फ्लेक्शन पॉइंट का मतलब ये नहीं होता है गुलजार जहां एक्यूरेसी मैक्सिमम हो या एरर मिनिमम हो. इन्फ्लेक्शन पॉइंट ऐसा रहता है जैसे कि sudden decrease, but after that it's going something like this. मतलब एक पॉइंट जिसके बाद चीजें डिक्रीज तो हो रही हैं बट बहुत ही स्लो, लेकिन उस पॉइंट से पहले देयर वाज अ स्टीप कर्व, आफ्टर दैट इट्स अ वेरी लो स्लोप. So that sort of a inflection point we talk about. There are multiple terms in physics and engineering for this point, but you can say this is an inflection point. Is it clear, Gulzar? It does not mean where accuracy is maximum or error is minimum. It is the point after which the decrease is not that steep or rate of change is not that fast. Absolutely, Gulzar. Does it mean the slowdown in the rate of change? Yeah. So your rate of change is now quite constant after this point, or is very minimal. Okay. And rate of change is what, guys, in terms of maths? Can anyone tell me rate of change is defined by which formula in field of mathematics? What is rate of change? Delta तो ठीक है, dy by dx, ये अपरकेशा, correct. The derivation, the derivative, right? The derivative function is the rate of change, which we were talking about even yesterday. Slope at this particular point, what is the slope? The rate of change. It is very fast. But if at this point I have to check the slope or rate of change, it is a bit of a straight line or a very slope is very less. So कोई भी चीज अगर आप मैथमेटिकली सोचोगे, यू कैन अंडरस्टैंड. लाइक गाड़ी में जो आप ब्रेक लगाते हो, एक्सेलरेट डीएक्सेलरेट करते हो, आपकी स्पीड चेंज होती है, मींस देयर इज अ डेरिवेटिव फंक्शन विच इज रनिंग. तो कल को अगर आपको एक टेस्ला टाइप की ऑटोमेटिक कार बनानी है और उसमें आपको एक्सेलरेशन डीएक्सेलरेशन के फंक्शंस इंप्लीमेंट करने हैं मैथमेटिकली, आपको डेरिवेटिव फंक्शंस कॉल करने पड़ेंगे. ओके. सिमिलरली, कैन एनीवन टेल मी if this is a curve and say this is a curve and I have to calculate area under the curve, which mathematical formula represents area under the curve in maths? Very good, Pragisha. So Pragisha, you are from maths background? Okay, good, very good. So yeah guys, you're correct. So its area under the curve is given by what? Say if this curve is having an equation f of x, if this equation is f of x, the integration of f of x with respect to dx, the x-axis, is nothing but area under the curve. But this integration is an indefinite integral. But if I am interested not on indefinite but a definite, as in only the area which is this, सिर्फ इतना रेंज में, मतलब say x is equal to 3 से x is equal to 6, so that is like integrate from 3 to 6, x की value from 3 to 6, so only this slice, that is known as definite integral or integration with limit. So that will also give you the area under the curve, but during that particular time frame. Okay, remember. So these things, मतलब मैथ्स भी जब पढ़ते हो तो सिर्फ फॉर्मूले नहीं पढ़ने हैं, आपको उनके पीछे का फिजिक्स या इंजीनियरिंग रीजन पता होना चाहिए. Okay, so you should know what is derivative is rate of change, acceleration or deceleration. Further, it's represented like this, right? D by dx of y. Then there is second order derivative, third order derivative और higher order derivative. उनका क्या मतलब है? तो read those. Similarly, there is definite और indefinite integrals. Like जो ROC curve का AUC हम निकालते हैं, उसके पीछे एक इंटीग्रेशन ही चल रहा है within those thresholds, जो हमने thresholds define किए थे, right? 0 से 1 तक के. तो understand this, these things. Sometimes you cannot take, say आपको 0 से 1 के अच्छा, वेरी गुड थिंग। जैसे हमने जो आरओसी कर्व बनाया था वो ऐसे जा रहा था, अगर मैं उसको 0 से 1 के बीच में कर दूंगा, 0 से 1 का एरिया निकाल दूंगा, तो वो तो हमेशा बेस्ट एक्यूरेसी आ जाएगी। इस केस में हमको इंटीग्रेशन को ब्रेक करना पड़ता है 0 से इस एरिया तक और यहां से अगले पॉइंट तक। तो इट वाज लाइक 0 से जो उसका एफपीआर था, 0 से जो उसका एफपीआर था वहां तक, और फिर एफपीआर से 1 तक, तो उन दो का सम होता वो। गाइस गेटिंग दिस? अगर मैं इस कर्व में आपको बोलूं एरिया अंडर द कर्व निकालना है, और आप बोलोगे राहुल आप तो बोल रहे हो यार 0 से 1, तो 0 से 1 चाहे मैं ग्रीन के लिए निकालूं या ब्लू के लिए निकालूं, वो तो सेम बात हो गई। तो भाई हमेशा ऐसा नहीं है, यहाँ आपको इसको पहले 0 से इसके एफपीआर तक, विच इज दिस मच जो भी आएगा, और फिर उसके आगे का जो भी है, तो इट इज लाइक 0 से एफपीआर से एफ प्लस जो उसका एफपीआर है वहां से 1। Getting it, guys? This is the application of integrations and application of derivatives, which we study in 11th and 12th. All of us have studied that in 11th and 12th. Application of integration and differentiation. Okay. So again, guys, let me see what is left. Yeah, we were talking about KNN, right? So few more important things in KNN. One second. Yeah, the another important thing is देखो इसमें भी आप एक्यूरेसी, क्लासिफिकेशन मैट्रिक्स, कंफ्यूजन मैट्रिक्स सब वैसे बनाओगे जैसे लॉजिस्टिक रिग्रेशन में बनाए, और यहाँ से भी एफपीआर टीपीआर निकाल के आप केएनएन को लॉजिस्टिक रिग्रेशन से कंपेयर कर सकते हो, उनका आरओसी कर्व एक दूसरे के साथ बना के। दैट्स सिंपल। बट नाउ द लास्ट क्वेश्चन, कैन यू, okay, can you नहीं, you guys are aware about different distance functions, right? Like Euclidean distance, Manhattan distance, Mahalanobis distance, but all this distance works on numerical data. What if some of the features are categorical, like gender, country? You cannot remove that columns, right? That columns are important. So can anyone ping me what you do if you have to do KNN, but it is categorical data? So what do? You drop that or you take care of that? Hamming distance, okay, Pragisha, good. Other than that? Okay. So all these which I'm showing on my screen, guys, are the possible options. I'll put this notebook also, updated notebook with KNN classification. So you have Tanimoto distance, Jacquard similarity, Dice coefficient, and cosine similarity. Okay. The most important one are Jacquard similarity, the Jacquard similarity and the cosine similarity. And then Hamming distance is also there, but Hamming distance has its own certain limitations. And then local sensitivity hashing, LSH, and indicator vectors. Don't go into this. This is sort of a PhD thing. But yeah, you can go into the other ones. Most important, I'm putting together these three: Jacquard similarity, cosine similarity, and Hamming distance. Gulzar, I'm not going into the details. You read about these, okay? I just want to understand and make aware अगर आप लोगों को नहीं पता है, क्योंकि KNN जब आपने किया होगा, आई डोंट नो कि उसमें कैटेगोरिकल डेटा था या नहीं, तो अगर कैटेगोरिकल था तो उसको ड्रॉप नहीं कर सकते। तो पहला तरीका तो ये है, आप उसको वन हॉट एनकोड कर दो। सिंपल है, सिंपलेस्ट तरीका है, वन हॉट एनकोडिंग कर दो उसकी। it will be working good, but not in all cases. Second, आप उसकी लेबल एनकोडिंग कर सकते हो, but label encoding is not a good thing. Okay, लेबल एनकोडिंग तब कर सकते हो जब वो डेटा ऐसा सा है कि ऑर्डिनल डेटा है, कि हाई लो लोअर, तब आप लेबल एनकोडिंग या ऑर्डिनल एनकोडिंग की सोच सकते हो. बट other than that, normally you go ahead with the Jacquard similarity, cosine and Hamming distance, these three, not the other ones. वो बस extra है, इनको ignore भी कर सकते हो आप, ये use नहीं होते हैं. Mostly these three are used: Jacquard, cosine and Hamming. So read about it. And again, as I said, drop me email if you still have any doubts on these things. But my purpose is just to discuss what you did in these. Okay. So we have to make sure we always use a categorical distance function also. We should know about Silhouette distance and elbow chart and the knee chart. We should know what is the differentiation integration, what role it plays in data science. Sometimes in interview they ask you कि ठीक है आपको integration differentiation तो पता है, but can you explain where in the field of data science you use it? तो differentiation कहाँ use हो रही है? Gradient descent, जहाँ आपका कन्वर्जेंस चल रहा है वहां आपका डिफरेंशिएशन चल रहा है, डेरिवेटिव, फर्स्ट ऑर्डर डेरिवेटिव. समटाइम्स दे आस्क यू कि मशीन लर्निंग में सेकंड ऑर्डर डेरिवेटिव कहाँ यूज होता है. तो दोज हु आर फ्रॉम मैथ्स बैकग्राउंड, ग्लोबल मिनिमा ग्लोबल मैक्सिमा निकालने के लिए वी हैव टू गिव सेकंड ऑर्डर डेरिवेटिव इक्वल्स टू 0, राइट. सेकंड ऑर्डर डेरिवेटिव इक्वल्स टू 0 आई थिंक टेल्स यू ग्लोबल मिनिमा और ग्लोबल मैक्सिमा, वन ऑफ दीज. बट I also don't remember see everything, guys. Okay, but yeah, that's where you have to do it. Okay, those who are from maths, they know this. Second order derivative for an equation equated to 0, you get what do you get, guys? Can you tell me, those who are aware about it? It gives you global minima or global maxima. Second order derivative equal to 0. Okay, if no one knows, please read it. Okay. And again, they ask you where you use integration in data science. So like area under the curve, that's one of the basic thing. There are other places also. Okay. The last question on KNN, guys, is why KNN is a bad model? Why it's not a recommended model? Can anyone tell me? Why KNN is a bad model? Even though its accuracy is always very good. KNN की accuracy हमेशा बहुत अच्छी होती है, 95, 94, मतलब not always, but आप N7 दे दो, 9 दे दो, you will get very good accuracies, whether it's regression or classification. But still people don't use it. Why? Guys, am I audible? Yeah, so why we should not use KNN? Guys, anyone, why we should not use KNN? Lazy learner. Very good, Varsha. That's the exact word. Anyone else? Absolutely, guys. There are two things. KNN को आप train करो मत करो कोई फर्क नहीं पड़ता. It's like it's not really learning anything. So means it's not deriving any formula behind the scene. Yeah, Vipul, that's also good. तो what happens is KNN में पहली प्रॉब्लम तो ये है, जैसे जैसे आपके नंबर ऑफ रिकॉर्ड्स बढ़ते चले जाएंगे या नंबर ऑफ फीचर्स बढ़ते चले जाएंगे, वो स्लो होता चला जाएगा. तो इट्स अ वेरी स्लो मॉडल, पहली बात. दूसरी, देयर इज नो मैथमेटिकल इक्वेशन दैट इट डिराइव्स एट द बैक एंड, लाइक y is equal to mx plus c टाइप की, मतलब कोफिशिएंट्स नहीं कैलकुलेट कर रहा. What it means is whenever you run it again, it will run on the entire data. मतलब अगर आपके पास ये बहुत सारे रिकॉर्ड्स हैं, ठीक है, and you want to say that for this particular person, tell me his nearest, मतलब his prediction, tell me his prediction. Okay, just tell me whether he will have cancer or not. So what it will do, it will go through this entire records, the entire data that you have, whether it is training data or test data. It goes through the entire data. If you have 1 million records, this particular poor guy will compare himself to all the 1 million people. Okay, and 1 million training records. Even though you have trained the model, It still goes through all the training records, and say your nearest value is 3. To just find 3 nearest neighbor, it will calculate Euclidean distance with all the 1 million values. Okay. Similarly, the another record, for identifying 3 nearest neighbor, it is calculating 1 million times, which is really not something good. Okay. And it needs a lot of RAM, lot of memory to run these models. And you always don't have that much memory. So that's why KNN people don't use, or they use the modified versions of KNN where they try to put some strategy to make it fast. But the layman KNN, this basic KNN, normally should not be used if your data is too heavy. If data is small, means less features and less observations, you use KNN, but you should never use it. And that's the question they may ask you in interview. So for every test record, it scans through the entire trained data. It does not learn anything. It just memorizes, as Rahul said. By memorizing, it means it keeps everything in memory. Means you need huge storage, huge RAM to process it. So the more the RAM you have, the faster the KNN is. And we know that RAM is costlier than hard disk, right? So that's the problem. So these are some important things you should know, guys. Most of you have given the right answers, definitely, to most of the answers. Yeah, Pragisha, correct. Yeah, we check second order derivative is greater than 0 or less than 0 to check for maximum minima, and those critical points are derived from the first order derivative. Right. You are absolutely correct. Okay, thanks, Pragisha. So this was all, guys, for today. Just give me 2 minutes. Okay. Yeah. So coming back to this thing, so we have talked about these two models, which does not support multi-class classification. So that's why what you guys need is OVR versus OVO. Remember that. The KNN, we talked about the elbow things and the all other stuff. The knee chart or maybe some other stuff which is involved. The best value of K. Some people say like square root of the observations, but that is still will be too high. But yeah, this is one of the formulas sometimes people use, square root of the number of observations, but still they may use elbow and knee or grid search CV to calculate the value of K. Okay, so now what we will be talking in the next class in detail from scratch is naive bias. I'll give you some basics today before we end the class about the naive bias, and then we'll talk from scratch in the next class. So naive bias, right, as a few of you are aware, is one of the very basic model, one of the very basic model, a very naive model, and uses Bayesian statistics. So that's by the name. The point why it's naive is, so if you are passing on 10 features, it does not care about the collinearity between those features, the correlation between those features. It says they are independent of each other. Okay, means the occurrence of one feature is not impacting the occurrence of other feature. Okay, that's what it says. So that's why it's naive, because in real world that does not happen. Then it talks about two things, the prior probability and the posterior probability. We will talk about this, what these are. Okay. So let's see this. Okay. So to understand naive bias, we have to understand conditional probability, and conditional probability is like probability of something given another thing already is known. That is conditional probability. We normally talk about probability of an event. We normally talk about probability of an event. Can anyone tell me the formula for probability? What is the formula for probability? Guys, probability, permutation, combination are all related. Formula for probability is, yeah, Nishta, favorable upon total, yeah, Varsha. So probability is favorable events upon total events. For example, if I talk about okay, so here we will talk about a lot of probability actually. So if I talk about there is a dice, what is the probability of getting an even number on a dice? Can anyone tell me? Probability of getting an even number when you throw a dice. Okay. What is the very good. Very simple, right? Because the favorable events are 3 and total are 6. Right? Absolutely. What is the probability of getting, okay, you are say throwing 2 dice. What is the probability of getting a sum of sum greater than 6? You are throwing 2 dice, dice 1 and dice 2. And what is the probability of getting a sum of this 6 or greater than 6? That means either both will give you 3, one will give you 3, another will give you 6, the sum is 9. So I'll give you 2 minutes. Do the calculation and tell me. If I throw 2 dice, what is the probability of getting a sum which is greater than or equal to 6? Okay, 12 by 36. Anyone else? 26 by 36, 12 by 6 factorial. Okay. 26 by 36. Okay. Okay. So I just want you guys to start thinking on this. Anyways, the purpose is not to exactly ask you to solve it right now. So we have 2 days off, like tomorrow and day after. So read about the probabilities, how to solve some of the basic questions. So this is one of the question I would like you to solve, not by pen and paper, but rather through formula. कुछ लोग सारे combination बना रहे होंगे बैठ के. Don't do that. The another question I would like you to solve is over the next 3 days before Monday. So there is that you can note it or you can listen it properly. There is this bag which contains red balls, green balls, or maybe other colored balls. Okay. So say there are 5 green balls, 5 red balls, 5 blue balls, and 5 white balls. 4 colors, 5 each. What is the probability of getting a white ball? Okay, if I randomly select one ball, what is the probability of getting a white ball? If I randomly select a ball, that's one thing. Solve it. It's fine. Then what if I am randomly picking 2 balls? What is the probability that they will be, say, both red? Okay, and another is, one is red, another is, say, green. So 3 questions I am giving you. If you are pulling one ball, what is the probability that it is belonging to any specific color of your choice, whether it's red, green, blue, it's on to you. But if you are picking 2 balls, A, what is the probability that both of them belongs to the same color? B, both of them belongs to different color. So this is another question I would like you to solve. And guys, there is a reason behind giving this question, because these are asked in data science interviews. Okay, probabilities is being asked, whether it's online, whether it's offline. These questions are asked to check how mathematically good you are. So solve these questions of probability. I'm not asking for our answers right now, but it's good if those who knows it. And definitely the permutation and combination. So all these things are related. So read about these. What is the factorial, like n factorial? Mathematically, what is the formula for n factorial? Okay, so read all these things. Then we will start about conditional probability in the next class. Like conditional probability is this is independent probability. Okay, this probability of this event is that this is an independent event. Remember, here when we say probability of an event E, it is an independent event. Here it's not the case. Here I'm saying probability of this given this. For example, probability of, see, you are receiving certain emails. Okay, you are receiving certain emails and you want to see whether it's a spam or not spam. So probability, you have to find what is the probability that a mail, given mail, is a spam. Okay, a mail is a spam given it contains particular words. So probability of spam, this is how naive bias works. Okay, but probability of spam given the email contains a set of words, a list of words. Say click, because spam emails ask you to take actions, normally click. Or money, normally they talk about money, right? So what is the probability of a mail being a spam given it contains these 2 words? So that's the conditional probability. Okay, इसको आप अपने कैटेगरी, अपने CSV फाइल के पॉइंट ऑफ व्यू से कैसे समझोगे? या कि आपको टारगेट वेरिएबल दिया हुआ है जिसमें वैल्यू है स्पैम और नॉन स्पैम, और आपको यहाँ पे फीचर्स दिए हैं जहां पर आपके वर्ड्स हैं. ईमेल के केस में हर वर्ड एक फीचर हो जाता है. क्लिक इज अ फीचर, मनी इज अनदर फीचर, और वो कितनी बार अकर कर रहा है, नंबर ऑफ अकरेंसेस, द नंबर ऑफ अकरेंसेस, वो उसकी वैल्यू हो जाती है. अगर मुझे नाइव बायस को यूज करके एक स्पैम क्लासिफिकेशन मॉडल बिल्ड करना है, नाइव बायस मॉडल गाइस नेचुरल लैंग्वेज प्रोसेसिंग की फील्ड में सबसे ज्यादा यूज होता है. नाइव बायस को नॉर्मली हम कैटेगोरिकल डेटा, ये जो अपना ऐसा CSV टाइप का डेटा रहता है ना, इस पे हम इतना यूज नहीं करते हैं. हम इसको ज्यादातर नेचुरल लैंग्वेज प्रोसेसिंग की फील्ड में यूज करते हैं, जहां पर आपके पास डॉक्यूमेंट्स होती हैं और आपको डॉक्यूमेंट्स को क्लासिफाई करना है. मान लो ईमेल इज अ डॉक्यूमेंट, राइट? सो वेदर इट्स स्पैम और नॉन स्पैम, तो जहां आपको टेक्स्ट डेटा की क्लासिफिकेशन कर रही है, वहां हम नाइव बायस को सबसे ज्यादा यूज करते हैं. जैसे कि मान लो आपके पास डॉक्यूमेंट्स हैं जिन्हें आपको क्लासिफाई करना है कि वो हेल्थ केयर डॉक्यूमेंट्स है, फाइनेंस के डॉक्यूमेंट है, तो आपको पता है कि अगर कुछ सेट ऑफ वर्ड्स मेरे डॉक्यूमेंट में है तो ये हेल्थ केयर की होगी, नहीं तो ये फाइनेंस की होगी. तो नाइव बायस इज अ बेस्ट फिट देयर. तो नेचुरल लैंग्वेज प्रोसेसिंग में डॉक्यूमेंट क्लासिफिकेशन की एक फील्ड होती है जिसको हम मतलब सॉर्ट ऑफ टैगिंग भी कहते हैं, डॉक्यूमेंट टैगिंग और डॉक्यूमेंट क्लासिफिकेशन, where we use naive bias maximum. Even the chatbots, right? When we build the chatbots, so we use naive bias a lot while working with chatbots because it's all natural language processing. Okay. Variable which are least likely to correlate even if we didn't participate. False message about winning of lottery. Okay. I'm ignoring all these things. I think whatever is going on, you guys are discussing maybe something or telling me something. But yeah. So here, if you see, the point is the conditional probability here plus this is, there will be a formula for this solving this conditional probability, which internally uses posterior and prior probabilities. I'll tell you. And here it keeps that these two features are independent of each other. Means क्लिक वर्ड का आने से मनी वर्ड के आने में कोई कोरिलेशन नहीं है, बट ऐसा नहीं है. ज्यादातर जब एक वर्ड आपके डॉक्यूमेंट में आ रहा हो तो दूसरे वर्ड्स आ सकते हैं बेस्ड ऑन द प्रॉब्लम यू आर सॉल्विंग. सो दैट्स वेयर इट्स नॉट ऑलवेज गुड बट पीपल यूजेस इट. दैट्स वाई हम नॉर्मल CSV डेटा जो आपके पास रहता है फीचर टाइप का, उसमें यूज नहीं करते इसको, बट डॉक्यूमेंट क्लासिफिकेशन में इसको यूज करते हैं. So guys, this is the conditional probability representation. Before we end the class, I'll show you one formula for this. We'll talk about this in detail. But if you see here, guys, these are conditional probabilities, like probability of A. Probability of event A given B means probability of a mail being spam, provided it contains particular word or a set of words, is probability of A intersection B upon probability of B. This is one of the representation. Okay, probability of A intersection B, guys, means probability of both of these things to occur together, always occur together, in which cases both of these happen together simultaneously. फॉर एग्जाम्पल कि ऐसा कब कब हुआ कि जब बारिश भी आई हो और सनी भी हो. इट वॉज सनी एंड रेनिंग बोथ. सो बोथ व्हेन अकर टुगेदर, देन यू टॉक अबाउट प्रोबेबिलिटी ऑफ A intersection B, and probability of A intersection B can also be represented as probability of A multiplied by probability of B for certain cases. So guys, read about the probability. There is lot to it, like probability of A, this symbol is known as intersection symbol. Then there is probability of A union B, like probability of A union B, like probability of either of these to happen, either of these, either this or both. Okay, so probability of A union B, probability of A intersection B, probability of A given B. If you know these, you will understand naive bias quite easily, which we will be talking. 1 second. So just I am making you familiar with the words or the terms in the field of naive bias. So probability of A given probability of B can also be written in a different form. जो पिछला फॉर्म था that is some other form, this is another form. हम इस फॉर्म को उस फॉर्म में कन्वर्ट कर सकते हैं, which I will tell you in the next class, because ये थोड़ा कॉम्प्लेक्स लग रहा होगा प्रीवियस जो अभी देखा था उससे. But you should remember, and what this means is you have to calculate this probability, the conditional probability, which is posterior probability. Posterior मतलब कोई चीज जो बाद में होने वाली है, as in just for a layman, और prior जो आपको पहले से पता है. Posterior means बाद में और प्रायर जो आपको पहले से पता है, फॉर अ वेरी वेरी लेमैन। ओके, तो आपको ये चीज निकालनी है यूजिंग दिस थिंग्स। तो इसमें आपके पास दो प्रायर प्रोबेबिलिटीज होती हैं, एक क्लास की और एक, okay, we will talk about this, that probability of a class where class is an independent event, like probability of spam. What is the probability of spam? Okay, out of total emails that you get in a day, what is the probability of an email being a spam? Okay, that's an independent event. Here is probability of a word. See, यहाँ मैं क्या कह रहा हूँ, probability of a spam given a word. So what happens here is, it's probability of the class upon the probability of the word. Yeah, correct guys. Probability of the class, probability of the word, provided both of these are independent events. They don't have any correlation to anything. And then the likelihood. अच्छा, एक चीज है guys, मतलब likelihood and probability is somewhat similar. Some people say likelihood, मतलब probability को वो likelihood कह देते हैं जब हम discrete variables की बात करते हैं, मतलब categorical variables की। तो उस तरह के जब आप predictions करते हो तो कुछ लोग probabilities को likelihood भी कह देते हैं। तो don't get confused, there is some slight difference, but likelihood is like probability only. So probability of spam given a word is probability of spam, probability of the word, and this is probability of word given spam. Means in, अगर मुझे पता है कि ये ईमेल स्पैम है तो उसमें एक पर्टिकुलर वर्ड के आने की क्या प्रोबेबिलिटी है। दिस सीम्स थोड़ा सा कंफ्यूजिंग बट इट्स वेरी इजी। मुझे पता क्या लगाना है कि मुझे एक ईमेल आई है, वो स्पैम है या नहीं, और ये मैं कैसे पता लगा सकता हूं, अगर मुझे उसके अंदर जो वर्ड्स हैं वो पता है। लेकिन उसके लिए मुझे पहले से कुछ चीजें पता होनी चाहिए। जैसे कि आज तक मुझे जितनी भी स्पैम ईमेल्स आई थी, जब मैंने उनका एनालिसिस किया था तो उसमें एक पर्टिकुलर वर्ड कितनी बार आया था। तो एक तरह से आप उसी चीज को रिवर्स में समझने की कोशिश कर रहे हो। तो ये आपका फॉर्मूला बहुत इंपॉर्टेंट है जिसपे पूरी नाइव बेस आपकी टिकी है। ठीक है, नाइव बायस। तो रीड अबाउट दिस, बट इज प्रायर प्रोबेबिलिटी, पोस्टीरियर प्रोबेबिलिटी, लाइक्लीहुड फॉर्मूला। Let me ping you this link. This is quite good. Just read from here. So in the next class, we will talk about it in detail. There are multiple kind of naive Bayes theorems or machine learning models, Gaussian, multinomial, and binomial. So we will talk in the next class. Yeah, next class will be on Monday, but I want you guys to study probability, permutation combination, and the Bayesian conditional probability before that, because तभी ये समझ आएगा, otherwise उसमें problem होगा. So read about this. And then there are different kind of naive Bayes algorithms, Gaussian, binomial, multinomial. We will talk about that. But yeah, just go through this. This is a good link. You will be able to understand it. Okay, guys. So thanks a lot for your time. We'll connect on Monday. Okay, read about all those things that we have been discussing. How can you once again tell our homework tasks, the questions which we are discussing? See, I'm thinking you. It's you have to read probability, you have to read permutation, combination, you have to read about the Bayes theorem, the Bayes theorem, whatever it is, and the two questions which I gave. Very simple questions. अगर आप दो डाइस को रोल करते हो, अगर इस पे मान लो 3 आया, इस पे 3 आया, तो मतलब सम हो गया 6, राइट? तो 6 या ग्रेटर देन 6 आने की क्या संभावना है, हमें उसका अनुमान लगाना है. ठीक है, पहला. दूसरा, अगर आपके पास एक अर्न है या बॉक्स है जिसमें कुछ आपके पास 5 तो ग्रीन बॉल्स हैं, 5 रेड हैं, 5 ब्लू हैं या 5 कुछ और हैं, तो आपको अगर रैंडमली कोई एक बॉल निकालते हो तो वो किसी एक कलर को बिलोंग करती हो, उसकी क्या प्रोबेबिलिटी है. रैंडमली कोई 2 बॉल अगर मैं निकालता हूं विदाउट रिप्लेसमेंट गाइस, देयर आर कॉन्सेप्ट्स ऑफ विद रिप्लेसमेंट एंड विदाउट रिप्लेसमेंट। मतलब अगर मैंने एक बॉल निकाल ली तो मतलब बॉल कम हो गई है इसमें से, मैं उसको वापस नहीं डाल रहा, तो ये मेरे जो क्वेश्चन है सारे ये विदाउट रिप्लेसमेंट वाले हैं। ओके, आप विद रिप्लेसमेंट विदाउट रिप्लेसमेंट दोनों से सॉल्व करना। मतलब अगर एक बॉल निकाल ली उसके बाद अगर 4 बॉल थी तो 3 ही बची हैं, वो होता है विदाउट रिप्लेसमेंट। उसमें आपकी प्रोबेबिलिटी फॉर्मूले बदल जाते हैं, विद रिप्लेसमेंट वाले में बदल जाते हैं, मतलब माइनर सा डिफरेंस आता है। तो सॉल्व बोथ विद रिप्लेसमेंट एंड विदाउट रिप्लेसमेंट। ओके, तो अगर दोनों बॉल सेम कलर की हैं उसकी प्रोबेबिलिटी, दोनों बॉल अलग कलर की हैं इसकी प्रोबेबिलिटी। और ये क्वेश्चंस मेरे पास्ट स्टूडेंट से पूछे गए हैं इंटरव्यूज में, इवन इससे भी कॉम्प्लेक्स पूछे गए हैं, तो प्लीज डोंट टेक इट लाइटली, दीज आर वेरी इंपॉर्टेंट। Okay guys, we'll meet on Monday with naive bias and we'll talk about this formula in detail. It's nothing more than this probabilities. Naive bias is nothing more than that. Just 3 types of naive bias are there, which we will implement in the next class. So please solve these and we'll start. Okay guys, thanks a lot for your time. Thank you. And please drop me emails if anyone have any questions. I will reply over email.